We're in.
Shall we play a game?
How about global thermonuclear war?
Hey there, HackerFrogs, it's me, the Shy Hat, and we're doing HackerFrogs AfterSchool today. We're doing HackerFrogs free hacking, we're hacking all the things. So what are we doing today? So we did a co-working stream yesterday, and unfortunately I wasn't able to stream to YouTube because my multi-streaming software, well, my multi-streaming app wasn't working. I guess I had some sort of configuration problems, but yeah. We did that yesterday, well, maybe 12 hours ago, and now we're doing Web App Wednesdays. So Web App Wednesdays, we're going to be doing, are we doing Web App stuff? We were going to be doing Web App stuff, but today we're going to be doing crypto stuff instead. Agent 57, hello, nice to see you here. I saw you in Panako Panko's chat. I'm not too sure what was going on over there because I wasn't really paying too much attention, but you were chatting a lot in there. Okay, so what are we doing today? So the first thing we're going to be doing is we're going to be warming up with a little puzzle game. It's called Order of the Sinking Star, and the demo is free. You can get it on Steam, and it's very, very, very fun. We're going to be checking out more of that today as our first topic, first hour of the day. Then we're going to be doing some demos from the OLIcyber cybersecurity education platform. We're not doing web app challenges. We're going to be doing crypto challenges. So cryptography, we're going to be talking about transforming information, all that good stuff. That's going to be the second hour of today's stream. In the third hour, we're going to be doing our HackerFrogs AfterSchool topic. And today, we're going to be doing a network hacking topic. We're going to be talking about brute force attacks. So brute force attacks against web forms, brute force attacks against SSH logins and stuff like that. That's going to be the third hour. In the fourth and fifth hours, maybe even the sixth hour, we're going to be doing a challenge from Vulnyx. Vulnyx is another one of these platforms where you can download vulnerable CTF boxes, and we're going to be doing the university box from that website. Okay, Agent says, Panko, not sure about the dudes though. I'm not too sure about the dudes either. Anyways, let's, what is this? Boss, hello, nice to see you here. Hope you're having a good day. All right, and let's get started into the first topic. So I'll put an hour on the clock, and then we'll get started. So if you want to watch some cybersecurity topics, the cybersecurity topic is going to start in about 60 minutes. All right, so without further ado, let's start up the game. You should be able to see it in just a few seconds. Okay, so what are we going to do? Are we going to do computer-generated voices or no AI-generated voices? So, I mean, let's just do the temporary computer-generated voices. It's fine. Okay, hello, boss. Nice to see you here. Alright, so what's going on? Oh, we were working on these mirror puzzles. So in this game, you have to get to the exit, and the exit in this case is going to be the orange pressure plate over there. We just need to stand on top of it. So what's preventing us from getting there? Oh, we can't push. So here's a stone that we can't push. So normally we can push stones in this game. So we can use the mirror to teleport ourselves to different locations. But we can't teleport into water. So, let me get a volume check on the game. Let me know if the game volume is okay. So I think... Oh, and we can also teleport the stone. So let's move the stone into position. So we can teleport the stone. Oh, I think what we want to do is we want to teleport the stone into a position where we can make a bridge. Volume seems okay to me. Thank you. Thank you very much for letting me know. So, I mean, we can teleport the stone over here. That doesn't really benefit us too much. Now, how do we teleport the stone into a position where we can push it around? Because of the nature of how the map is laid out, we'd have to put this stone in one of these rows in order to create the bridge to get the other side. Although I guess, what else could we do? We could also try to cross ourselves, but there's not enough room for us to cross ourselves. I mean, we need to get a good amount away from the mirror if we want it to teleport us. Yeah, this doesn't seem to be... Although... let's put this a little bit farther away. How about over here? So if we could get about as far away as we could... I mean, we end up in the water then. It's not what we want. Okay, let's back up. Yeah, so this mirror, this block, this rock over here, blocks line of sight. There's got to be something I'm missing. So we can put this over here. Okay, so if anybody in chat has any suggestions as to what we're supposed to do, I'm open to suggestions. If we put it down here, and we have this crystal. We can teleport the crystal over here, but I don't know if this helps us very much. You need to hack the planet, buddy. Yeah, I guess we need to. Push the stone and the mirror close to the bridge. Push the stone and the mirror close to the bridge. And Kamakut, hello, nice to see you here. Okay, so if we... So we can teleport the stone from one place to another. And I bet, yeah, we can't teleport the stone while we're standing in the way. Where would we want to put the stone? The stone needs to go in the gold thing? It's not the stone that needs to go in the gold thing. It's us. We need to stand on the gold thing. So we need to either drop the stone into this gap here to make a bridge to cross, or we need to find a way to teleport ourselves onto that side. Oh! Wow, wow, wow. I just kind of lucked into it. So I guess we needed to... Alright, next level. Yeah. The thing about playing puzzle games on live stream is that sometimes you can look really dumb. Even when you're solving the puzzles. Alright, so what do we need to do next? We have this crystal here. We need to drop the crystal somewhere? Okay, we got the mirror here as well. So we can teleport ourselves over here. We've already done these puzzles. So the placement of the mirror means we can only... Where can I drop this stone? Oh, we can teleport the stone. Okay, so if we... But what do we get if we teleport the stone? I mean, we can teleport it over here. And then where our way is blocked. And then we can teleport ourselves. And then we can drop the stone into... Whoops. We can drop the stone into here. And then that means we can move the mirror. We can't move this mirror. Okay, we can't move the mirror. Alright. Oh, it's because it's against a wall. Alright. Guess we'll back up. So making the bridge over there wasn't a very good idea. Okay. Yeah, we can drop the stone over here to make a bridge. And then we can go cross that bridge, and then access the next puzzle. Good.
So, will I meet the Murites now?
In time, perhaps. It's not needed today. We, they, and I prepared everything you need.
Okay, so we need to drop the stone into this gap here to create a bridge so that we can cross over to the side where the exit is. So maybe we can... Let's move... Just for fun, we'll just move the stone over here, because this drops it into the ocean, which is not what we want. Okay, this is all blocked. Oh, awesome. Alright, exit.
The Murites are all about avoiding contamination. I love them for that.
Had I gone this far, I'd have been better than I am.
Perhaps. Perhaps in more ways than you'd have been worse. But you'd not have developed many of your current virtues, which I enjoy.
So something tells me that the two people talking have some sort of intimate relationship. I can't prove it, but I'm not too sure what the relationship is between the two people talking. Okay. Is it Imuji? Or is it Elamuji? Let me know how to pronounce your name on YouTube. Thank you very much. Alright, so... Where do we want to go from here? We need to cross. We don't have enough. We don't have enough resources to just drop the stone into the water to get to the exit. At least I don't think so. So the way we can move this mirror down here and then over. And then over here. It's an eye emoji. Okay. So it says they could be as intimate as being the same clanker. The same clanker? I mean, I'm pretty sure that both of these voices are done by real people. I'm pretty sure that they only give the AI-generated voices to like really minor characters. Where are we supposed to go? If we point the mirror over here, we don't get access to it anymore. Maybe we need to put the mirror, like, lay down the stone first, and then teleport to the other island. Because if we're metagaming this, we can't solve the puzzle without getting access to the top left island. So we need to find a way to get there first. But it looks like there really isn't a way for us to build a bridge to get there. So we're not building a bridge. Okay, teleport the mirror into the water, and then teleport to the other rock. Okay, Jay Lopez, hello, nice to see you here. Teleport the mirror into the water, and then teleport to the other rock. Teleport the mirror into the water. I mean, let's reset the level. So we can teleport the stone as well. Maybe we need to teleport the stone somewhere. Push the stone to the water and then the mirror on top of it. Okay. Al Hadi Pasho, hello, nice to see you here. So the question is, where do we want to put the rock? Do we want to put it... Whoops. Do we want to put it, like, up above, maybe? So if we put the stone here, drop it over there, and then put the mirror on top, this is not quite far enough to get us onto the other island. Okay, so we need to go back. If we put it onto the one beside it, that doesn't really help either. Maybe we need to drop this stone over here. No, that's not quite far enough either. Hold on. Maybe we can put the stone here, and then put down the rock and then teleport onto the rock. Put down the rock. I mean, we can get to the other island now. So that's, I mean, I guess this is progress. From here, we just need to use another rock. use another rock? Because we can teleport the rock. Whoops, that's not what I wanted to do. We can teleport the rock over here, but then now we can't get to the other island. Is there something I'm missing here? We can teleport onto the island here, and now we've got access to this rock. I think I might have put the mirror in the wrong place, because I can't really do anything with the mirror anymore. I can't move it. Let's reset the puzzle. So we'll reset the puzzle. Instead, we'll put the rock over here. And now we can teleport like this. And then we can put... Oh, maybe we teleport this over here and then stand on top. Although this doesn't help us either. Okay, let's back up. Here's the problem. Anytime I go over to this island, if I want to drop this, if I want to teleport this rock anywhere, I'm not going to be able to go back to the same side, to the same island. So, Oh! Okay, yeah, okay, now I can teleport this here, and then I can teleport myself on top, and then I can get access to the exit. Yeah, J. Lopez, I think I caught on to your idea there. Thank you.
Virtues that will avail you henceforth.
Virtues like skill and money? How does that benefit here?
You weigh bonds that shift as you hold them. Tend constellations of fickle allegiance. Of what use could all that be? I wonder.
So, the first thing we need to do is we need to find our way over to the top right island. I'm thinking what we need to do is we need to maybe teleport one of these rocks into the position up here. Let's try pushing here. Okay. ASCII Taurus says, this isn't CTF. The CTF stuff is going to start in 38 minutes. 39 or 38 minutes. We're just doing a warm-up right now. So we're playing a little game. We're exercising our problem-solving abilities. Whoops. So we can put the rock over here. And then teleport on top of it. Maybe if we push both of these. That doesn't help us too much. Okay, I'll check back. In your brain technically is a muscle. Good warm-up. Yeah, I mean, we're just trying to... We're trying to learn different systems, and as hackers, we're always trying to figure out how to interact with these systems. So... we can drop the rock here, or we can drop the rock here. Neither of these moves really gets us where we want to. Because if we drop the rock here, and then we teleport on top of it, there's only one path that we can take, so we need to back up. And maybe we'll back up to where we can still move the mirror around, because when we move the mirror into the corner, we really can't do very much with it. So where do we want to put this mirror? Where do we want to put... Oh, I think I see. We want to put the rock maybe a couple of squares over from where I am. But we really can't reach that far. Let's back up. We need more distance. We need to be one more square over. Okay, Al-Hadi Pasha says the mirror on the single block on top. The mirror on the single block on top. Oh, you know what? That might work. Here, let's give that a try. And then move it over. Yeah, this works. This works. Thank you very much for the suggestion, El Hadi. Okay, and then teleport over. And then... we want to teleport these rocks. Put the mirror on the top of the island so that the rock can be teleported to the right of the bridge. Yeah. Thank you for the suggestion, Kamakut. So the next thing we need to do is we need to teleport these rocks over. So we can put these in the way. We can't adjust the mirror anymore. Hold on. So we could teleport it into the middle of the water. Jay Lopez says, "Can you pull the mirror or just push?" We can only push. So the mirror is basically stuck in place. So we have two of these stones that we can push into the water. But I don't think pushing them into the water from this side is what we want to do. Maybe. We can put ourselves over here, for example, and then teleport the rock over here. How are we brute forcing the possibilities? Are we supposed to be doing some brute forcing here? I mean, there's only so many logical possibilities, I suppose. So we can... if we wanted to drop a stone... Let's teleport over here. Then we'll push this. Oh, maybe we need to put... Okay. I think what we need to do is we need to... I think what we need to do is we need to unlock the mirror. So if we can teleport the stone over. And then teleport ourselves over. Then we can unlock the mirror again. And then start using it. Whoops. Like over here. Only we need to... Yeah. Now we can get to the exit. Awesome. Well, solve that one. Now we've got access to more puzzles? Okay, sure. What is this? So X is reset? What are we resetting? Oh, we're resetting the stone. Thank you. Okay, so... that unlocked some stuff. I think we can teleport the stone over again. So teleport this, and then teleport... Oh, we can't teleport ourselves after this. Actually, wait, we can. We can just move over here. Okay, and then are we supposed to move something on top? Oh, I see. We need to... move this over here, and then we can get access to a new area. Alright. And looks like we can't teleport with this mirror, but there's a puzzle for us to do.
Your path has not been wrong, but this is where it turns.
And now I feel so warm. So this is what you want. To ever draw me forward. So far forward as to leave behind everything I know.
It's not merely what I want. It is what will happen.
Okay, so we need to get on the other side. So where can we stand? Where can we put the mirror so that we can get onto the other island? I think we need to put the mirror in a place where we can actually move it around. Maybe like this? Yeah, okay, so we can teleport here. And then this mirror... I think we need to move this over to this side. This doesn't help me. Or do we have the mirrors, like, face each other? Because here we can teleport back and forth. Oh, interesting. So we can have the mirrors bounce off of each other, and that lets us get access to places we couldn't before. Awesome, solved.
I have a wife. I have a child.
Yes, you do.
Okay, so we can now teleport using the two mirrors. Okay, and then move on to the next area. So these are both puzzles. This leads to a new area. These are more puzzles. Okay.
Will I see them again?
If you want. And if you want. If you see them again, you'll be a better man for them and for you.
So what's going on with this mirror? Usually the mirrors let me teleport, but this mirror isn't really responding, the one up at the top. So where do we want to go? I think we want to line up this mirror with the other one. So I can teleport here, and then I can drop this stone, and then I can start moving the other mirror around. But what's up with this mirror at the top? It's not working like the other mirrors. This, if I teleport myself here, I'm just gonna fall into the water. So if we put the mirror on the same... Maybe we need to do this. Maybe I want to end up on the top over there. So to do that, I would need to move this over here, and then like this. Okay, so now I can drop the stone and then move the third mirror. So we need to find a way to bounce 3 mirrors. And then maybe get to the other side. Huh. These mirrors are kind of weird. So this is a different type of mirror. I wonder what... We need to figure out what the rules are. Because this mirror by itself... Oh, I think I understand. So this mirror only works if it has something to bounce off of. It only works if it's bouncing off of another mirror. Huh. So the mirror we have doesn't really... So this'll bounce me in a direction. But what if I'm down below? If I'm down below, then... Okay, let's try putting this mirror like, right up against the other mirror. Maybe not this one, maybe this one. Okay, so this bounces this way. Play with teleporting from the bottom mirror. Teleporting from the bottom mirror. This will put us further away. And then maybe... What happens if I increase the distance? So teleport, so the... hold on. So I want to get all three of these to interact. So if I push this right up against here, and then... so this bounces off 1, 2, 3, 4, 5, 6. And then I can start moving in this direction. So how do I want to arrange this? So just for fun, we'll try this. Oh, awesome. So now I can get to the other side. And that's it.
Will I see them again?
If you want, and if you want, you'll bring your son a gift greater than any you ever brought back from a courtesy voyage.
So we can get onto this side. Alright, so we need to use these two mirrors to get to the exit island. So the exit island over on the right-hand side. Okay, maybe move this down. And maybe just rearrange the positions of the mirrors. Put it on the same row as this one. So we definitely can't move the mirrors onto the other islands. We could move them, like, further along here. Oh, but we can't move this mirror at all. Alright, we're gonna need to step back. Back to when we move this one in place. Figuring out where we're supposed to be putting these mirrors is really, it's kind of tricky. Maybe just for fun we'll put this way at the bottom here. Although, this doesn't lead us anywhere good. Maybe we'll put this one over here. Oh. Wait. Are we allowed to make clones of ourselves? So I saw in another puzzle that we were able to clone ourselves by putting the mirrors in certain places. But cloning ourselves also created some weird scenarios where we couldn't finish the level. So for example, if I clone myself and one of my clones dies, like this, then I can't finish the level anymore. The exit becomes black, and we can't finish. Okay. Jay says, for sure one mirror has to be on the same axis of the island you need to land on. Yeah, that's true. So it's got to be on the same row. So it's either going to be on this row or this row. And then the other mirror has to be perpendicular to it. Oops. So if we were to do this, let's move it a little bit closer. But this only gets us to this island. Oh, hold on. So we want to put ourselves like... Yeah, we can extend our range like this by teleporting onto another island. Maybe... I think we're getting closer. So we can teleport here, and then from here we can extend our range. Alright, we've managed to do it. Great. Done.
If I don't want,
Then you won't want. It is I who set the Mirrites on their path, and I who now send you, not to them, but past them, along a path your own.
This mirror bouncing stuff is a bit hard to grasp sometimes. So maybe we can do this. Yeah, so this gets me over to this island. And then... I'm guessing we need to... But now this crystal... We can't move it into a place where we can teleport it over to the other side. So maybe this is not the way we want to do it. Okay, let's reset. So is there a way for us to teleport to the other island? This is not enough. So the way the level is laid out, we can't push this rock into the path of the mirror now. Okay, so I think what we need to do is we need to find a way to... We need to find a way to teleport onto the other island without using both mirrors. Although I'm not too sure how we would do that. missing 2 spaces. Maybe we want to teleport onto the other side of the island. Something like this? No, that's the wrong mirror. These mirrors don't bounce off of each other. So it's got to be this mirror that leads us down. Although, can they be arranged in another way? Yeah, we can arrange it like this. But this doesn't get us onto the other island. Here's something I wonder. Like, we can push the mirrors into the water, but what happens if we push 2 mirrors into the water, into the same space? They both break. Okay, great. Actually, so if we push a mirror into the water, the mirror doesn't act as a mirror anymore. So it's basically kind of like a dead item. So I can get onto the other island. Oh, you know what? Yeah, okay. We can teleport the stone now. Because we can get back onto this island, and then we can move the mirrors out of the way. But this teleports the stone way too far. Okay, hold on. So teleport the stone way down. Okay, if we move this up, and then over, and this over. Yeah, this will teleport the stone into the water, but the stone is in kind of a weird position. We want it to be like over a little bit. Yeah, so we want it to be there. So we teleport it there. And then we want to go to that. We want to go there ourselves. Hold on. Whoops, we just drowned. Okay, we can teleport over here, but from here. Okay, let's reset. So we just need to find a way that we can use the mirrors to get onto the island, but still have the mirrors in a place where we can move them around. So like this, we need to be down 1. Okay. And then we need to move the stone into a position where it can be accessed by the mirrors. So over here maybe? Actually, no, up. No, it can't be up. It has to be on this row. Then we go over here. Whoops. So one more time, this teleports the rock a little bit too far. Oh, these mirrors are blocking each other. Hold on, let me go back. Let me go back to the point where I can still move the stone. So I think this needs to be up one. Maybe like this. And then we'll teleport over, and then we'll... Okay, so that teleports the stone way too far over. Maybe like this. I think you said there are hundreds of levels to this game. Well, the full game is going to have hundreds of levels. I think the demo only has less than 100 levels. Not that less than 100 levels is not a lot. It's actually a lot. So this teleports the stone into place over here. We just need to teleport ourselves onto the stone, like this. Okay, and then we finish the level. Jeez. Every time I finish a level, it feels like I'm dumb.
A path that only you may blaze.
But Red Sly Fox, hello, nice to see you here. What did we unlock? So this is another mirror. And this leads to another area. Okay. What is this place? So these are teleporters? Ah, okay. So this is the mirror aisles. And this is the original area with the block pushing adventurers. I think I'm gonna go back to the heroes over here. Okay, so what did we not solve in this area? I think there was one puzzle down here. Okay, so we've got this hero, and this hero can't be attacked by the monsters. The other hero is the teleporting guy, and the teleporting guy is a bit... His power is a bit weird. Because... So the teleporting guy teleports into... He swaps positions with whatever object he's looking at. But he has to swap, no matter what. Okay, nitro-based. Learn hacking, don't play. I mean, we're exercising our minds. We're trying to figure out how to do problem-solving stuff. And hacking is problem-solving. So nitro-based, I think you should rethink what your definition of hacking is. Most of hacking is basically understanding the system and how to take advantage of it. If you don't learn the system, you can't do the hacking. But we're supposed to switch over to the next topic in like 2 minutes anyways. Anyways, so I think what we need to do here is we need to put we need to put the monsters all next to each other. So these monsters, if we put them next to each other, they'll all kill each other. And that's what we need to do. If you can't play the game, you can't hack the system. If you don't know the system, you can't hack. So we need to find a way to have our wizard guy in the middle. So he needs to be in the middle between these guys. And he also has to not die, which is the other part. And the monster over here has to be standing in this space where this guy is. Where my person is. Oh, that doesn't work. Okay, the moment he teleports, he is not protected anymore. Okay, so we can't do that. Anyways, we've run out of time for the warm-up, and we'll just finish off the game, and then we'll move on into our demonstration topic. Alright, everybody, we're going to be moving on into topic number 2. Let me go ahead and change the overlays. And while we're doing this, we might as well listen to some music, so I'll put my, my hacking playlist on. Just a second. There we go. If you ever feel like the music is too loud, let us know, and we'll try to adjust the volume. So what are we doing now? So we're going to be doing some cryptography demonstrations, so let's go ahead and set that up. So the game I was playing was Order of the Sinking Star. You can get the demo for free. And it's got a lot, it's probably got like 5 to 8 hours of entertainment, depending on how quickly you can solve these puzzles. Alright, so where are we? We're going to be doing some demonstrations from aulicyber.it. If you want to make an account yourself over here, it's free, and they've got a lot of good resources for learning cybersecurity challenges and concepts from a bunch of different topics. So they've got network security, miscellaneous, web security, cryptography, and software security, which is a combination of reverse engineering and binary exploitation. What we're going to be demonstrating today is we're going to be demonstrating 3 of the beginner cryptography challenges over here. And let me go ahead and get that set up. We're going to be doing this for about an hour or so. And if we finish early, we might do some more puzzle games, who knows. Okay, so this is the first encoding challenge. The thing about this website is that it's originally in Italian. I don't think they have an English version of the website. Let me check. So we got light mode and dark mode. If we go home, is there like is there a language selection? No, there's not. So the site is in Italian. But we can always do a translation of the website. So go over here and then go down to translate page. We'll translate from Italian to English. Okay, and we'll go down to cryptography. And we're going to be doing the first 3 challenges from the cryptography challenges here. And before we start, let me get my demonstration, my presentation file. Where is it? So encoding 1, and we got the PDF files. Okay, let us begin. Alright everybody, this is a guided walkthrough for the Crypto 1 Encoding 1 challenge from OLIcyber.it as part of their introduction series of challenges on cryptography. So the challenge description says, in this series of challenges, let's go ahead and make this a little bit bigger. In this series of challenges, you will be introduced to some basics necessary to address the problems of cryptographia. So I'm pretty sure this is the Italian word for cryptography. So first of all, it's good to understand the concept of encoding. An encoding or code is a system of signals or symbols conventionally designed to represent information. At a fundamental level, each information is represented within a computer using a sequences of zeros and ones. This is called a bit. However, these are rather uncomfortable. As a result of them, they usually overlap further in coding depending on convenience. The the translation of the website is a bit off, I guess, because the AI generated translation is not that great. But anyways, we're talking about ASCII. ASCII, for example, is a standard code that allows you to represent text and some other control characters through a sequences of 7 bytes, equivalently integers from 0 to 127. In Python, the function chr converts from numbers to characters, and the function ord does the opposite. Otherwise, you can get help with online tools like CyberChef. So it says here that the flag of this challenge can be obtained by converting or decoding these numbers into the corresponding ASCII characters. So what they have here is they've got a number of different numbers, and what we need to do is we need to convert the numbers into ASCII characters. So what's going on here? Let's talk about this. So this is OLIcyber Introduction Crypto 1 Encoding 1, and in this challenge, we're asked to understand the concept of encoding to start learning cryptography. But what is encoding? So encoding is the process of transforming data from one form to another, usually with the goal of storage or transmission using specific systems. So the reason why we convert letters into numbers is because at its essential core, all computers understand are binary numbers. So we need to feed the computer a set of binary numbers that can be transformed into another representation. So binary, this set of binary numbers, is equivalent to decimal 65, which is equivalent to hexadecimal 41. And if we encode that using ASCII, we get the uppercase A. Do a ternary, do a ternary. Okay, encoding is not cryptography. So if you say that encoding is cryptography, people are going to get very upset, because the goal of encoding is not to transform information to keep it secret, but it's still useful to illustrate how data can be transformed. So ASCII is an encoding method that is used to transform letters, numbers and symbols, and other characters to code points, which map to specific numbers. So if you were to go online and you were to look up something like something called the ASCII table, you'll see that the numbers or the codes associated with ASCII are over here, and not all of them are printable characters. For example, they've got null characters, the start of a heading, the start of text, and these are all formatting or control characters. The actual printable characters are these characters here from code 32 to 127. So for example, we've got 32 as the space, 33 is the exclamation point, and then we've got the numbers over here. So 48 is the number 0, 51 is the number 3, and then in the alphabet we've got the uppercase letters starting with 65 for uppercase A. Mealyman says, today I learned that Astro in dev mode serves absolute URLs that can be useful to hackers. Astro in dev mode. I'm not familiar with Astro, but what is Astro, Mealyman? Thank you. So let's talk more about this. So this challenge requires us to convert a list of decimal numbers to ASCII characters, which is the act of encoding them. So for example, if we wanted to do this manually, we could look these up one by one. For example, 102, decimal 102 on the chart is lowercase f. So we would record lowercase f and then go back and then get the next one, 108, and 108 is lowercase l, and then keep on going from there. Fortunately, we've got automated tools to help us here, and we'll illustrate how to do this with a few different methods. Mealyman says Astro is a JS framework, JavaScript framework, which is used to develop content-heavy websites. Interesting. I'm not really much of a developer, but thank you very much for letting me know about that. Okay, so if we wanted to solve this challenge using CyberChef, the first thing we would do is we would take all of these numbers and then we would go over to the CyberChef website. So CyberChef is a pretty common tool that we use to do data transformation. If you go over to cyberchef.io, you'll see an interface that looks like this. What we want to do is go over to the challenge and select all of the numbers without these brackets over here. The square, without the square brackets, copy this, go to CyberChef, and then in the CyberChef input window, paste in the numbers, then go over to your operations over here to look for an operation to do on these numbers. In this case, we want to do from decimal, and what this operation does is it converts decimal numbers into ASCII characters. So click and drag into the recipe window, and then we get our flag. So the flag is numbers already. Numbers already. All right, so that was solving this challenge with the CyberChef. There's a couple of other methods we can do as well. So the next method, so what we did there was, in the operations window, search for the from decimal operation and drag that selection into the recipe window. So the operation will convert the decimal numbers to their ASCII character equivalents, which we can see in the output window. So the second method we'll use to solve this challenge is using Linux commands. We can solve this challenge using Linux commands by using the echo, tr, and awk commands. So often in Linux, you want to use multiple tools at once, and you pass the output of one tool into the input of another tool. First, we echo out the list of numbers for use with the other commands. Second, we pipe that output into the tr command, replacing the commas with line breaks. So in the output, we want to get rid of our commas, we want to replace them with separate lines. And the third thing we do is we use the awk command, which transforms the numbers into its ASCII character equivalents, and then print them out next to each other. That's what this awk command is doing. So let me go ahead and grab the command. So I'll go over to my terminal, and then I'll paste in the command. So the thing is that I didn't grab all of the numbers. So let's grab the numbers one more time over here. So copy those numbers and then paste into the echo. So we echo out the numbers, we replace the commas with new lines, and then we use awk to print out each one of the ASCII characters transformed from their decimal representation. and then printed next to each other. And that way we also get the flag. So the third method we would use is using a Python script. Let's talk about this. So to solve the challenge using Python, we can use the whole list, including the square brackets, as a list variable. So up here, we create a variable called numList, and then we paste this in. Then we create an empty string called flagString, which we will later populate. So flagString is going to hold our flag, but we initialize it as just an empty string. Then we run a for loop over here, over the number list, which adds the ASCII encoded character of each number in the list using the CHR function to the flagString variable. So for I in numList, flagString equals flagString plus CHR function on I. And then finally, we print out the populated flagString variable which contains the flag. So let me go ahead and get the script. So we'll copy the script, then in our terminal, we'll create a file called OLICrypto01. Okay, and then we'll paste in the script contents. So we got our number list, we've got our empty flag string, and then we run a for loop over all the numbers in the number list to populate the flag string, encoding the numbers into their ASCII equivalents, and then we print out the flag string. So we can save out the script and then run the script. What? Oh, gotta spell everything correctly. Invalid syntax. Hold on. Oh, I didn't copy the whole thing. Okay, let me grab that list again. Copy, and then paste in the list, then save. And then run the script, and we get the flag. Alright, everybody, that was 3 different methods to solving this challenge over here. The Crypto01 encoding challenge from aulicyber.it. If you enjoyed this guided walkthrough, please click on the like and subscribe buttons on the video, and leave a comment underneath the video. But until next time, HackerFrogs out. Alright everybody, we're going to be doing 2 more of these challenges, and they become more and more complex as we go along. So let's go ahead and do the second one. Let me grab those files. Okay, and let's start. Alright everybody, this is a guided walkthrough for the Crypto 2 challenge, encoding 2, from aulicyber.it as part of their introduction to cryptography challenges. So the challenge description says, conventionally the bit sequences are divided into bytes, and adjacent subsequences of 8 bits each. So bytes are 8 bits. Hexadecimal encoding, or base 16, allows them to be represented in a very convenient way. Given a byte, it is broken down into 2 adjacent sequences of 4 bits each. These, read in binary, can be understood as 2 integers from 0 to 15, which are then represented by the characters 0 to 9, and then A, B, C until F. So for example, we've got this binary number. This came out a little bit garbled. Prof Excellent TV has subscribed on YouTube. Thank you very much for the subscription. But anyways, each byte is then transformed into a 2-character sequence. In Python, byte sequences are managed through the bytes class. With the method .hex, you can get the corresponding hexadecimal string, while the function bytes.fromHex, returning the object bytes matching the hexadecimal string. So to get the flag, turn the following string into the corresponding byte sequence. So we've got a hexadecimal string over here. We'll talk about this in, well, let's talk about it right now. So this is OLIcyber Introduction Crypto 2, Encoding 2. In this challenge, we're asked to decode hexadecimal strings into bytes. So what are these hexadecimal strings? So a hexadecimal, or hex string, is a number of pairs of hex digits which can be encoded into bytes, which then can be rendered as ASCII characters. So for example, if we've got the hexadecimal string 41424344, it can be encoded into ASCII characters A, B, C, and D. So all of these capital letters over here. So the 41 is associated with A, the 42 with the B, the 43 with the C, and the 44 with the D. Okay, so this challenge requires us to convert a hexadecimal string into a byte sequence, in this case, printable ASCII characters. So to solve this challenge, we can use a few different methods, and the first method we'll be using is CyberChef. To solve this challenge in CyberChef, first we need to copy the hexadecimal string, and then paste it into the input window. So let's go ahead and do that. So here is the string of hexadecimal digits. We'll copy it, and then we'll go over to CyberChef. Hold on. Let me reset CyberChef. So to use CyberChef, you just need to go over to cyberchef.io, and you'll see an application that looks like this. So the information that we want to transform, we're going to paste it into the input window. And then in the operations window, we're going to search for the from, oh, not the from decimal operation. This should say from hex. Sorry. So we need to use from hex and then drag from hex into the recipe window. Okay, the operation will convert the hexadecimal numbers to their ASCII character equivalents, which we can see in the output window. So let's go ahead and do that. In CyberChef, search for from hex, and this operation is going to convert hexadecimal byte strings back into their raw values. So we drag this into the recipe window, and then we get the output, which is ASCII characters. So flag hexadecimal can be a bad babe. Hexadecimal can be a bad babe. Okay. So we can also solve this in a couple of different ways. The next method we're going to be using is using Linux. So we can solve this challenge using Linux commands by using the echo and the xxd commands. 556, hello, nice to see you here. So the first thing we do is we use the echo command to feed the hexadecimal into the next command. So basically, the echo is used as input for the next command, which is the xxd command. So the xxd command is used to convert the hexadecimal string into a printable string. So when we run xxd with -r, it's going to do a reverse operation from hexadecimal into bytes. The -p in the command is going to give only the printable characters and not the usual interface. Okay, so let's go ahead and demonstrate this. Okay, here's the Linux command. I'll copy it, and then in our terminal, we're going to paste in the command. So we echo out the hexadecimal string, and we have to make sure that this is contained within some quotes, either single quotes or double quotes. We then pipe it into the xxd command, which is usually used to create hexadecimal from whatever bytes are given to it, but we're running it in the reverse operation, which is hex to bytes, and we give printable output. So this is what we get when we run this series of commands. We get the flag, these numbers have been transformed into their ASCII bytes, and then printed out. Alright, so that was using Linux, and we've got one more method to look at. Okay, so the last method we're going to be using is Python. To solve this challenge with Python, we can use the hexadecimal string as a string variable. So we just need to grab the string, and then create a string variable inside of Python. We'll call it hexstring. And then in another variable, we're going to run the bytes.fromHex method to convert the hex string into its bytes equivalent. So bytes.fromHex on the hex string, that's going to create a bytes object, which we call flag bytes. So finally, we print out those bytes, which prints out with no problems, since all the bytes are printable. Not all bytes are printable, but these ones are. So let's go ahead and demonstrate that. Over here, we got our Python script. I'm going to copy it. And we'll create a script called OLICrypto2. Paste in the script. Okay. And so we have our hexadecimal string. This is a string object. And then bytes from hex on the hex string, we save this as the flag bytes variable. And then we print the flag bytes variable, and that should be it. SysOS says all bytes are printable if you print them in hex. That's true. But not all bytes are printable if you don't print them in hex. We'll save out the script, and then we'll run the script. Okay, and this prints out a bytes object over here. Flag hexadecimal can be a bad babe. Alright, so that was solving this particular challenge with 3 different methods. And this was a guided walkthrough for the Crypto 2 Encoding 2 challenge from aulicyber.it. If you enjoyed this guided walkthrough, please click on the like and subscribe buttons on the video, and leave a comment underneath the video. But until next time, HackerFrogs out. Okay, we've got one more one more challenge to go through. The next one is going to get a little bit more complicated than these ones so far. So this is encoding 3. Let me go ahead and bring up the files we need for this. Okay, and thank you 55676167. Okay, so this is encoding 3. Let me get the presentation file for this. Alright everybody, this is a guided walkthrough for the Crypto 3 Encoding 3 challenge from aulicyber.it as part of their introduction to cryptography challenges. And this is all in Italian. Let me translate this from Italian to English. So translate page. This page is translated from Italian to English. Hold on. Why didn't this translate? Okay, let me try reloading the page. Okay, and then we'll try translating one more time. So from Italian to English. It looks like it looks like the description here doesn't want to translate for some reason. That's weird. Hold on. Let me see if I can get the translation tool to work. Oops, not Indonesian, please. Okay, let's bring that. This isn't translating. Italian to English, please. Translate. Okay, so now it seems to be translating. Let me bring up encoding 3. This still doesn't translate. Huh. Oh, no. Okay, it's translating now. Great. Alright, so the challenge description says, often in cryptography you have to deal with whole numbers. These are usually transmitted using various encodings of corresponding bit sequences. However, you usually avoid using base 10 representation, preferring a more extensive character alphabet for the reasons of compactness. Possible alternatives can be hexadecimal, as seen in the previous challenge, or base 64. So we're talking about a new encoding system. An example of a snippet in Python which decodes a string in base 64 is this one over here. So the first thing to talk about is translating base 64 encoded strings using Python. So we can also do base 64 encoding in Bash pretty easily by echoing out anything we want, for example, test, and then base 64. So basically what this does is it transforms this information into another encoding. In this case, it's called base 64. And I think we'll just skim over this because we don't need to know all this stuff right now. Although we do need to know about endianness. All right, let's go over this really quick. So in Python, to convert an object from bytes into an integer object, it is convenient to use the function int.fromBytes. So with the bytes and the endianness as the arguments. So the b is our byte object, and the endianness is a string. So it could be big endian or little endian bytes. So we're basically talking about whether or not the bytes are read from left to right, which is big endian, or right to left, which is little endian. Indicates which order of the bytes, respectively from left to right or vice versa. So to convert a whole, what is this? A whole something in bytes, we can use the function z2bytes n endianness. So basically what we're doing here is we're converting an integer. Wait, are we using an integer? I think this should be an integer. So it indicates the number of bytes to be used for conversion, followed by the order given by endianness. So 2 bytes is, it's supposed to be an integer method, which converts an integer into bytes. So we have to specify the number of bytes we want to convert it into, and then the endianness, which can be big endian or little endian. What is endianness? It's a nice word, but what does it mean? Okay, so I'll explain over here, sure. So we're talking about byte endianness. So bytes can be read into the system in one of 2 orders. So there's big endian, which reads from left to right, and there's little endian, which reads from right to left. So an example of big endian. Thank you very much. Whoa, Panako Panko was on for a really long time, and you're raiding in with the party of 22. Thank you very much, Panako Panko. Thank you for the raid. If you're interested in VTubers, if you're interested in streamers that are a little bit zany and nutty, then definitely check out Panako Panko. Let's give her a shout out. Shout out Panako Panko. There you go. Oh, I'm not logged into Twitch over here. Just a second, everybody. I've got to log into Twitch. Funny. Nullsec asks, who's Panko? Just a second, I'm going to give her a shout out. I just need to log into Twitch. And Nullsec, nice to see you here. We just got a raid from Panako Panko. She's another live streamer who does cybersecurity content. Yeah, Panako Panko, she does hacking content. She's probably better at doing network hacking exercises than I am. She also does a lot of VTuber modeling, and she's also a very chill person. Anyways, so big endian. So big endian, these are bytes that read from left to right. So for example, if we were representing these bytes with hexadecimal characters, so we could do 41, 42, 43. So this would be ASCII ABC, and we feed it in from left to right order. But if we're doing little endian, it reads from right to left. So if we were to do the same sequence, it would be 4-3, and then 4-2, and then 4-1. Just followed her. I'll check her out. Yeah, she's very cool. She's very cool. My favorite Swedish VTuber hacker. Do you know why endianness isn't standardized? I think it depends on the architecture of the CPU. I think x86, so x86 chips, their default endianness is little endian, but some other chips might feed in their information in big endian order. Okay, let's continue. So the flag of this challenge is broken into two halves, decoding the first part from base 64, while the second part is converted from the given number in base 10 in bytes in big endian. So we've got two things to decode in this case. We've got a base 64 string, and then we've got a really large decimal integer. Okay, so let's talk a little bit more about this. So in this challenge, we're asked to decode two objects into bytes, a base 64 encoded string, as well as a large integer. So the first thing we'll talk about is base 64 strings. So base 64 is a common encoding system which transforms bytes into alphanumeric strings, which may include the plus and slash characters. So the complete base 64 encoding character set is over here. It's lowercase letters, uppercase letters, numbers, the plus sign, and the slash sign. So when we talk about base 64, it's because there are 64 items in the set. Just like in base 10, there's 10 items in the set, and in base 16, which is hexadecimal, there's 16 symbols in the set. Okay, so for example, if we were to take some basic 64 encoded strings, so test becomes this, HackerFrogs becomes this string, and 123 becomes this string. So here's some sample base 64 encoded strings, as well as their original ASCII forms. So we can so note that base 64 encoded strings must always be a length that is divisible by 4. If it is not, a number of equal signs will be added to the end of the string until the length is divisible by 4. So this is 4 characters. This is 2, 4, 6, 8, 10, 12, 14. This is 15 characters, and then an extra one to make it 16 so that it's divisible by 4. This is 2, 4, 6. This is 6 characters, plus an extra 2 equal signs to make it divisible by 4, to make it 8, length of 8. Okay, so the other thing we're taking a look at is we need to convert a large integer to bytes. So this really big number, we need to turn these into bytes. So any byte string can be converted to a decimal number, but first the byte string must be converted into a hexadecimal string, and then that hex string is converted into a decimal integer. I'm sure you can also do it directly, but this is the method I know to do this. So if we've got the ASCII characters ABC, we would convert these into their hexadecimal equivalents, which is 414243, and then we would convert this hexadecimal number into a decimal number, which is, what is this? This is 4,276,803. Okay, and we can also do it in reverse. If we've got the really big number, we need to convert the decimal number into a hexadecimal number, and then convert the hexadecimal string into bytes, in this case, ASCII bytes. Okay, so we're going to solve, this is going to take a bit of time to solve. The first thing we're going to be taking a look at is how to solve the first part using CyberChef. So to solve this challenge in CyberChef, first we need to copy the base64 string and then paste it into the input window. Then in the operations window, search for the two base64, this should say from base64. The from base64 operation, and then drag that selection into the recipe window, and the output will be in the output window. So let's demonstrate this. So here, we'll just grab the base64 encoded string. We'll go over to CyberChef. And then we will paste in the base64 encoded string in the input window. So from here, in the operations window, we'll search for from base64, and then we will drag this operation into the recipe window. So from here, we've got the first part of the flag. Flag, wait, it's all something something. Okay, so that was just the first part. But the first part, we're going to be solving it with a couple of other methods as well. So if we want to solve... Oh, sorry, we're doing part 2. So for part 2, first we need to copy the large integer and then paste it into the input window. So the big number, we paste it into the input window, and then in the operations window, search for the to base operation, then drag into the selection, drag that selection into the recipe window, and adjust the radix to 16. So what this is going to do is it's going to convert the really big decimal number into base 64. Then, in the operations window, search for the from hex operation, then drag that selection into the recipe window below the to base operation. So basically what we're doing is we're doing two operations. One operation to convert the decimal number into base 16, and then the other operation to translate the hexadecimal into bytes. Okay, the operations will convert the integer to hexadecimal, and then convert the hex string to bytes, which we can see in the output window. Okay, let's demonstrate this. So here, the big number, we'll go over to CyberChef, and we will paste it into the input window. From here, we'll search for the operation to base. So this one over here, drag it into the recipe box, and then the radix over here is going to specify the base we want to convert to. In this case, it's going to be 16. So we see here that the decimal number has been converted into hexadecimal digits. Then we'll apply a second operation, which is from hex, and that's going to convert hexadecimal bytes into, it's going to convert hexadecimal strings into bytes. So we'll just drag that into the recipe window underneath the to base, and then we get the original second part of the flag. So what we would do to solve this challenge is grab the two parts of the flag together and then paste them together. Okay, so that was solving it with CyberChef. There's a couple of other methods we could do as well. So to solve this using Linux, the first part, we would do base64d for decode. We have to echo in the command. So we can solve this method using, so you can solve the challenge using Linux commands using echo and base64. So the first thing we do is we use echo to provide input to the second command. So echo the base64 string, then pipe it into base64 decode. Okay, you use the base64 command with the -d argument to decode from base64 to bytes. Okay, let's demonstrate that. So here's our base64 string. In the Linux terminal, echo out the string and then pipe it into base64 decode. So that gets us the first part of the flag. Echo, echo, echo. Yeah, it's interesting. I thought when I first learned about Linux, I thought the echo command was kind of useless, but it's not useless at all. It's actually very useful. Okay, and the second part, we have to use a combination of the echo, BC for binary calculator, and XXD commands. So the first part is using echo, which we use to pass the output base. So in this case, we want 16, we want hexadecimal digits, as well as the number itself. And then we pass that into the second command, which is the binary calculator. So the binary calculator is going to convert the decimal number into hexadecimal. And then after we have a hexadecimal number, we can pass that into the XXD command to convert from hexadecimal to bytes. So the -R and -P arguments reverse bytes to hex, reverse the bytes to hex, and then present it in a printable form, respectively. Okay, so as Master says, especially in scripts or when combining with other tools. So echo combined with a lot of other tools, it's very, very useful to use inside of Linux. Okay, so let's go ahead and demonstrate this. I've got this command over here. Okay, so echo. So the output base is going to be hexadecimal, which is 16, and then the really big integer number. We pipe that into the binary calculator command to create hexadecimal numbers, and then we pipe that into XXD, which is going to reverse the hexadecimal to bytes operation and then print it out. Okay? So if we print this out, if we do this without the XXD command, then we just get the byte string. Sorry, the hexadecimal string. Null6 says, I've never used BC, interesting. I mean, if you do a lot of CTF exercises, you're going to be introduced to all sorts of new tools and commands that you never really have encountered before. Okay, so the third method is using Python. To solve this challenge with Python, we can use the base64 string as a string variable and the very large decimal number as an integer variable. So we got our base64 string and we've got our big integer. Okay, we also need to import this base64 decode function from the base64 module as well. Okay, @val asks, what is echo? Echo is a Linux command. Echo is a Linux command which outputs whatever you give to it. 3D Code Warrior, hello, nice to see you here. Hope you're having a good day. Okay, we set a base64, a decoded base64 string variable using the b64 decode function. So we run this function on the base64 string to create another variable here. And then from the decimal, for the decimal to bytes conversion, we need to do two things. We need to calculate the byte length of the big number by using the bit length function divided by 8 because there are 8 bits in a byte. So in this case, the big integer over here, we're going to get the bit length of it and then divide that by 8 because there are 8 bits in a byte, and this is going to give us our required bytes. We're going to feed that into the 2 bytes method. We use the integer 2 bytes method to convert the integer to a bytes object, specifying the required bytes value for the number of bytes and the byte order parameter set to big for big endian byte order. So finally, we print both parts of the flag, and that is going to finish out the script. So let's go ahead and demonstrate this. Here, okay, so here's our Python script. We're going to create a new script called OLIcyber crypto3.py and paste in the script. Okay, so we've got everything that we need over here. First we import our function, then we've got our base64 string, we've got our really big integer, and then we're going to calculate our required bytes by taking the big integer, get its bit length, add 7, because just in case the bit length is too short, and then do a floor division by 8, because and that'll give us the required number of bytes we need to get. So to do base64 decode, we run base64 decode this function on the base64 string, which we save to a variable called base64 decode. The integer bytes is going to be the big integer, so this one over here. We run the method 2bytes with the arguments required bytes, which are calculated over here, and the byte order, which is big endian. So it's going to be read from left to right. Finally, we print out both parts of the flag, which is B64 decode and integer bytes. So let's go ahead and save this out, and then we'll run the script. Okay, and then we get a bytes object, which is ASCII bytes. Flag, wait, it's all bits, always has been. Okay, all right, everybody, that was 3 different methods for solving the Crypto 03 Encoding 3 challenge from OLIcyber.it as part of their Introduction to Cryptography series of challenges. If you enjoyed this guided walkthrough, please click on the like and subscribe buttons on the video and leave a comment underneath the video. But until next time, HackerFrogs out. All right, thank you for sitting through my demonstrations of these. If you have any questions about any of the commands we did or any of the Python script that we used, let us know, and we'll try to answer your questions as best we can. We got 12 minutes left. Null6 says, I always forget you're recording. No worries, no worries. I'm happy to answer anybody's questions or comments during the live stream. It's just that I need to turn these into YouTube videos eventually, because I need to keep myself in the YouTube algorithm. Anyways, we've got a little bit of time, so maybe we'll do some of these thinky games. We got 10 minutes, and we're currently on puzzle number 41. So in about 10 minutes, we'll start our next... Oh, you know what I forgot to do? I forgot to change my overlays. Silly me. So we're currently doing topic 2, topic 3 is on deck. Okay, so what is this this puzzle? So this puzzle is called Nurikabe, a popular puzzle type introduced by the Japanese puzzle publisher Nikoli in 1991. So shade a fully connected group of cells, ensuring that the numbers are left in unshaded regions of that size. So each number must be enclosed in an unshaded region containing as many cells as indicated by the number. So this 2 has to have a 2 unshaded regions. So the 1 needs to have 1 unshaded region. The 4 needs to have 4 unshaded regions, etc., etc. But there are a few different rules. Each unshaded region must contain exactly 1 number. All the shaded cells in the grid must form one group connected horizontally or vertically. So the shaded portion of the puzzle, it all has to be connected. So we can't have anything that's unconnected, like this over here. So we need to find some way to connect them all. Okay, all the shaded cells, right, okay. And shaded cells must not form any 2x2 blocks, and therefore no blocks larger than 2x2. So we can't have any shaded or unshaded squares, or like cube type areas. Okay, let's go ahead and try solving this. Alright, so what do we have? We've got 6, 5, 4. So the 1 is very easy to do. And because these all need to be connected, this has to be one of our shapes. So the 2 is probably going to be like this. And then the 3, I'm not too sure. I mean, the 3 might be something like this. I'm actually not completely sure at this point. Okay, we also need to make sure that the shaded areas are all connected to each other. Then again, we've got a 5 over here. The other big rule for Nurikabe is that we can't have any 4x4 blocks. We need to break these up. So how do we do this? Maybe the 4 can be like this. And then the 6, we can also use the 6 region to break up some of this white space. So 1, 2, 3, 4, 5, 6. Maybe like that, but that's got a bunch of 4x4 regions as well. So this can't happen. So maybe the 4 needs to snake up into here. You have a 4 block next to the 3. Yeah, that's true. That's true. So we need to find some way to break this up as well. Maybe the 5 region can be like this. 1, 2, 3, 4, 5. Something like that. But this isn't connected anymore. So this region is disconnected from the rest of this. So maybe it has to be 1, 2, 3, 4, 5 like that. But that doesn't work either. Maybe we can do this. 1, 2, 3, 4, 5. And then 4 like this. And then we need to find some way for the 6 to break up all these areas. Because we can't have anything like this. We also can't have like a 6 shape that has a bunch of these 2x2 blocks. This is not allowed. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Maybe we can extend like that. Oh, this creates a 4x4 block. So we can't do it like that. So the 4 has to be included. So here's a 3, here's a 2, here's a 1. Okay, Red Sly Fox says, "Are you sure Panako Panko is a hacker streamer? I take a look at her videos and like, what the heck is this? She is she does do cybersecurity stuff, but she hasn't been doing very much cybersecurity stuff lately because she's been focusing on doing VTuber model commissions as her work. So unfortunately, she hasn't been doing very much hacking because she has to make her money by doing 3D modeling stuff. Okay, move the 6 main line 1 row down so it points up. So it points up. So it points up. 6 main line so that it points up. Null 6 has got to pay those bills. Yeah, she's actually very talented as a 3D modeler, but she also does hacking content. It's hard to tell because most of her stuff is like VTuber and like 3D modeling focused stuff right now. Okay, let's get some hints. So the simple techniques of surrounding the 1 and expanding the shaded regions won't get you very far today. We learned a more advanced Nurikabe trick in 1.30. Do you remember it? What was the advanced trick? Oh, sorry, we've got an ad going on Twitch right now. So when the ads go on Twitch, we'll put on some birds. Okay, we'll be back in about 30 seconds. I just need to have a little water break.
Hey! Who are you people? What do you want from me?
You want the numbers, Mason. You want the numbers. That's all we've ever wanted.
Okay, so if you know what game that's from, then you're a gamer. I actually don't remember what game that's from. Is that from Call of Duty, or is that from another game? We want the numbers, Mason. Anyways, okay. So no idea? Okay. Reachability. Since every unshaded cell must be part of the numbered region, if a cell is too far from each number, it must necessarily be shaded. Count carefully. Every unshaded cell must be part of a numbered region. If a cell is too far from every number, it must necessarily be shaded. I have no idea. The last one I haven't tried. So 1, 2, 3, 4, 5, 6. So this is 6, but we've got these customers here. So the big problem for this puzzle is this upper right corner, upper left corner. We need to make sure that we break up the 4x4 blocks. Otherwise, we're going to be in trouble. 1, 2, 3, 4, 5, 6. But then we got a bunch of 4x4 blocks over here. The 2 and the 3, the 1 and the 2, these are set. We need this to be here. Call of Duty Black Ops. That's what the search says. It's really interesting that you can do like a quote from a video game, and it'll tell you what the video game was. So we want the numbers, Mason, is Call of Duty Black Ops. Yeah. So this 4 could go in a few different directions. We also can't have maybe like this. So the 5 is here, the 6 is 1, 2, 3, 4, 5, 6. But this doesn't qualify because we've got this these 2 4 blocks. Let's get another hint. Reachability should have given you a few shaded cells on the left edge. A few shaded cells on the left edge. Which then lets you mark some cells with an X because you can't have any 2x2 blocks of shaded cells. I'm not too sure how, what is the word? How deduction works in this case. So we can't... So if we've got shaded cells, and we have to make sure that there are no 4x4 blocks, then we have to make sure that this is not a shaded cell. And we have to make sure that this is not a shaded cell. But we can't make it part of the 6 block here. One, 2, 3, 4, 5, 6. 1, 2, 3. Yeah. The big problem is reaching over to here. 2, 3, 4, 5, 6. To break up this. I mean, we could do this as our 4. If this is all connected. So here's our 4, here's our 3, here's our 5. But in this case, we've got these blocks over here which we need to take care of. Anyways, we'll come back to this some other time because we've got to do our HackerFrogs AfterSchool topic. So we're going to be moving on to topic number 3. It's here, and topic number 4 is on deck. At least we have 3 squares now. Yeah, okay. Let's do 60 minutes. So what we're going to do is we're going to do our education topic. I guess the last couple have been education topics, but this one is part of a program that I developed. So it's called HackerFrogs AfterSchool, and we're going to be using links from this document over here. Alright, so this is HackerFrogs AfterSchool Network Hacking Session number 6. Welcome to HackerFrogs AfterSchool. This is the 6th session for network hacking. Let's go over the concepts we covered in the previous session. So in the previous session, we were talking about password cracking, which is kind of like an analogous activity to brute force attacks, which is what we're doing today. Password cracking is the act of determining the plaintext of a password hash by hashing a string and comparing it to the password hash. So there are a couple of different ways to identify the type of hash that is being used, including CLI programs and web applications. We took a look at cracking zip file password hashes. We took a look at cracking SSH private key hashes, and we also took a look at cracking Linux password hashes. But today, we're going to be doing something different. We're going to be talking about brute force attacks. We're going to practice brute force attacking a login page, and then we're going to try brute force attacking an SSH login. So, what are these brute force attacks? Brute force attacks are attempts to determine legitimate usernames and passwords on online services. Brute forcing is similar to, but not the same as, password cracking. So we're going to be using a special room from TryHackMe to learn about brute forcing. So it's TryHackMe/room Hydra, and I think the link can be found over here. Okay, if you have a free account over at TryHackMe, you should be able to access this room. And let me go ahead and reset my progress over here so we can start fresh. Okay, so if you've never used this room before, you're going to have to click on the green Join Room button to get access to it. So the other thing we're going to do is we're going to scroll down to task number 1. So in the task, the literature here talks about the Hydra tool. So Hydra is a very common tool used for brute forcing a bunch of different protocols and a bunch of different systems. I remember this room. Yeah, it's a pretty good room. Okay, read the above and have Hydra at the ready. We'll click on check. Okay, and then we will go over to task number 2, using Hydra. So we're going to set up our virtual environment by turning on the virtual machines. So under task number 2, there's 2 buttons I want you to press. So there's the green Start Lab Machine button, and then the Start Attack Box button. So the first button is going to activate the vulnerable web application that we're going to be attacking. And the second button is going to activate the attack box, the, Linux machine that we're going to be using to attack the website. So click on Start Lab Machine. And then click on Start Attack Box. So these 2 machines are going to take a couple of minutes to initialize. and then we're going to be able to interact with the room. In the meantime, we're going to talk about what we're going to be doing today. Okay, so brute force attacking a login page. So a very common target for brute force attacks are web app login pages. We're not going to be using Hydra to attack the login page. We're going to be using another tool called FFUF. So when we try to do different types of hacking activities like brute forcing or password cracking, we might have a few different tools to use because different tools are good at doing different activities. So we're going to be learning how to do login page brute force attacks using the FFUF program. We're also going to be using the Burp Suite program, which is another very common web app security tool. And Burp Suite can be used to record HTTP request data, and it's very convenient to pair Burp Suite with CLI programs like FFUF and SQLmap, and also Hydra. Okay, and we're going to be talking about saving our web request to a file, but we're getting a bit ahead of ourselves. So let's go back to TryHackMe. We need to wait for the attack box to initialize. It should be finishing up in just a bit. Okay, so in the attack box terminal, we're just going to click into this and hit the enter key to dismiss this window. For this room, I think it's better if we put the attack box in its own tab, in its own browser tab. Actually, maybe not. The first thing we want to do is we want to record the IP address of the vulnerable web server. So we're just going to open up a terminal here. So pick one of these, open it up, and we're going to save our IP variable. So IP equals this this IP address right here. So whatever IP address you have, just type it in, 10.144.131.203. Okay, so whenever we want to access this, we just do $IP, and it's going to put in the IP address. So from here, what we want to do is we want to put the attack box in its own web browser tab to make the interface as big as possible. So we'll go over to the center of the screen and then go down to the bottom. At the bottom of the screen, there's a view in full screen button that we can... I have an IP address, can you hack it? Well, I mean, I wouldn't want to. Let's click on the view in full screen button down here. Okay, so this is going to put our attack box interface into full screen, which is what we want. I give you permission, of course. Alright, so from here, we've got our IP address. We're going to, well, since this is a machine and we're doing network hacking, typically the first thing we'd want to do is we'd want to run an nmap scan on it. So we do -p-, we run T4, we run very verbose, and then we give the IP address over here. Paste in, where is it? Well, let's just give the %IP. Sorry, the $IP. Okay, and we will scan the box, and it gives us 2 ports. So there's port 22 and there's port 80, which are open on the server. Typically, I begin with the ping to see if ping works. Yeah, that's also another good thing to do at the beginning of a network CTF exercise. You just do ping on the IP address you've been given. Okay, and then if you get ping responses back, that means you definitely have access to the machine. Ping pong. All right, so our IP address, we're just going to copy it, and we're going to try to access this from inside the attack box web browser. So it's not your web browser, but it's the web browser inside the attack box. So click on the Firefox shortcut button up there. And it should take a little bit of time for the web browser to start up. That's because everything's a little bit slower when you're using somebody else's virtual machine. Okay, paste in the IP address, and then we can put an HTTP in front of it. Okay, we've got our Hydra over here, and we can try to log in. So admin test, click on login, and it says your username or password is incorrect. Okay, so what we want to do is we want to record the information for this login using our favorite tool, which is Burp Suite. So we can minimize our web browser, and then we can start up Burp Suite by using the shortcut over on the right side of the screen. So it's called Burp Suite Community Edition. This is the free version of Burp Suite. This is going to take a little bit of time, so let's talk about what we're trying to accomplish here. So using Burp Suite, we're going to open up the Burp Suite browser, which is attached to the Burp Suite proxy. From the Burp Suite browser, we're going to try to log in, and the login request is going to be recorded in the Burp Suite proxy, which we can then look at to get the login information. So all the information that was sent in the login request. So to save a request to a file, we would open up Burp Suite, open up the Burp Suite browser, and then record a test login on the desired web page. So let's go back to TryHackMe, and this still hasn't started. It still hasn't finished booting up. That's fine. We'll just wait a little bit longer. Okay, so this is Burp Suite inside of the attack box, which means it's going to be a bit slow. So in Burp Suite, to start it up, click on Next, and then Start Burp. And there's a couple of, what is the word? There are a couple of settings you need to adjust inside of Burp Suite when you're using it on the attack box. So inside of Burp Suite, I think we can set up a dark mode. Let me go ahead and do that. So we can click on the settings window, and we can just type in dark. Appearance, theme, light, dark. And now we're real hackers. Yeah. Okay. All right, so from here, we're going to type in browser. So inside of, so here, there's going to be two options. There's going to be browser data and then browser running. What we want to do is we want to check this box over here. Allow Burp's browser to run without a sandbox. If you don't check this, you're not going to be able to run the Burp Suite browser on the attack box. So go ahead and click on that. And then... Actually, I'm also going to adjust the font sizes, because the font sizes are pretty small by default. So I'm just going to make these fonts nice and big so that we can read them properly. And the display, I'll also set it to 24-point font. Okay, that might be a little bit too big. Let's make it 20-point font. Let the darkness flow. Alright, so we can get out of here, and then we can start up the Burp Suite browser. So we'll go over to the proxy tab. All the tools inside of Burp Suite are inside these tabs. So dashboard, target, proxy, intruder, repeater, etc. So click on proxy, and then intercept is turned off, good, and we'll click on open browser, this button. So proxy and then open browser. Okay, and now the browser that opens up, this is connected to the Burp Suite proxy, and we're going to paste in our IP address, and then we're going to try a test login. So the username is admin, and the password is, we don't know. We're just going to type in test, try to log in. Your username or password is incorrect. Okay, that's fine. We just needed to record the information in the Burp Suite proxy. So minimize the browser, and then we're going to go over to, in the Burp Suite interface, proxy HTTP history. Proxy HTTP history. Okay? We can see the details for our login request. So it was a post request to the login endpoint. So we can click on that. I think everything's a bit too big. I'm gonna have to adjust my settings one more time. So font size, we'll set it to 16. Okay, so we see our response. Ooh, this is really big. I think I might have made everything too big. I'm going to start adjusting this stuff one more time. So the message editor will make this 16-point font as well. Okay, this is a little bit easier to look at, but still not that easy. Okay, so this has all of our post-request information that we sent over to the server. And what we want to do is we want to save this request so that we can give this information to CLI tools like FFUF and SQL map, but we're not using SQL map today. Anyways, right-click on the request and then select copy to... Sorry, let me get my notes. To save a request to a file, first open Burp Suite, then the Burp Suite browser, then record a test login on the desired web page. Okay, Weekly Pickup says, so brute force attacks utilize every combo possible until it finds it. In that case, wouldn't it be more useful against pins rather than passwords? Or would dictionary attacks be limited in real-life scenarios? I mean, there are a lot of things that get in the way of brute force attacks, but when they're actually allowed by the system, they can be very, very effective. Okay, so from there, locate the login request, select it, then right-click the request and select Copy to File. Copy to File. Okay, let's go ahead and do that. So here, right-click, Copy to File. Wait, did they change the name of the... Is it Save Selected Text to File, or is it Save Item? Because it seems like they've changed some of the stuff in Burp Suite. Because I don't see the Copy to File selection anymore. Maybe Save Item. Okay, let me give it a shot. Request.txt, and it looks like it's being saved inside the root folder here. We'll save this, and then we'll try taking a look and see if it's got the right information. Okay, this is not what we're looking for. Let's go back to Burp Suite and we'll try to save this again. So they renamed the copy to file command. Let me see if I can search for what the command is called now. Burp Suite copy to file command renamed. Okay, the copy to file command has not been renamed. Has not been renamed. It remains available in the right-click context menu as copy to file, which allows you to save either selected text or the entire message. Could somebody confirm for me that copy to file doesn't exist in Burp Suite anymore? Let's see. So save item is not it. We're looking for... It's not copy URL, it's not copy links in response, it's not save item. Because I've got my notes, and the notes say that I've got I typed it in Google and it says it was renamed to save file. It was renamed to save file? Okay, let me give it a shot. Save item. But we did save item. Yeah, this is not it. Maybe it was saved to file, and no, AI isn't always correct. Isn't that the truth? So it's not save item, it's not copy. Maybe we need to do copy as curl command. Copy as curl command, that doesn't make sense either. This was something I used to do all the time before. Anyways, we'll just skip this. We'll skip this step. Maybe we'll okay, so we're just gonna skip this step. We're gonna do Hydra. So there are a number of programs that can brute force SSH. I guess we'll start with SSH and then we'll go back to the login form first. But we can't really do that. Yeah, so originally Burp Suite had a command called copy to file, which we could use to create our thing. Actually, I'm just gonna start a Burp Suite on my own machine, just so I make sure that I'm not going crazy. Okay, we've got ads running on Twitch right now, so we're just going to I would take a little break, but I have to confirm this for myself. Okay, so this is my own version of Burp Suite here. Proxy HTTPS 3, this, right click. Yeah, copy to file is gone. Save item, copy links. So let me try So the AI says that copy the context menu. Okay. Copy. Maybe it's just copy. No, copy to file is here. Hold on. So it's a different context menu. So copy to file appears here, but if you click here, copy to file is not here. So I need to click on the correct window. So maybe click on the request window. Scroll up to the top. Just when you think they can't make Burp Suite more confusing. That's true. Okay, so in here, so in the list, if you right-click on the request, you don't see copy to file. Okay, it's not here, but if you click on the request window and then right-click, then you can copy to file. You're trying to save the request? Yeah, so what I'm trying to demonstrate is this. So if you save this to request.txt, so this request, if you save it, and I'm doing this in my own machine, not the attack box. So this will get all of the request information to make the same request to the web server. So it includes all of the headers that you send. Waffler, hello, nice to see you here. But for some reason, it doesn't want to cooperate with me. In the attack box. Oh man. Okay, let's... This is maddening. You know what we can do? We can do this manually, okay? So we just copy everything here, right? Highlight everything, copy it, and then manually paste it into a file. So nano request, sorry, I'm in the wrong window. Close this out, and then in our terminal in the attack box, nano request .txt, and then delete everything here, and then paste in this information. So this is the exact request information here. So that we sent username admin and password test. We're going to be using this file with FFUF to do our brute force attack. Okay, so we'll save this out. And then, so save the request, and then run FFUF with the request file. So the last step before running FFUF is to edit the request file and specify a fuzzing point inside the request. So this is where we're going to be doing our brute forcing. So in this case, it'll be the password parameter. I think we were given the username Molly in the description for the challenge. So if we go back to the Try Hack Me page, it says use Hydra to brute force Molly's web password. So we're given this the username. So we're just going to edit the request file. We're going to go down. We're going to change the username from admin to Molly. And then we're going to change the password to our fuzzing point, which we indicate with the word fuzz, all in caps. Okay, save this out. And now we're going to pass this over to the FFUF tool. Let me get the command syntax for that. So if you're wondering where our notes are for this exercise, Red Sly Fox says, brute force on a server, wouldn't you get timed out for too many requests per minute? I mean, it depends on the server. There are lots of variables involved in brute force attacks. There's lots of things that can get in the way. Okay, so this is the FFUF command over here. I'll just paste it into chat in case you want to take a look. Okay, so in here, we're gonna paste this into our clipboard. So that we can use it. Oh, why did this not paste in? Okay, so this is the command. We'll close this out, paste this in. So FFUF, we're going to use a request file, request.txt. We're going to use a word list, which is user share word list rocku.txt, which is a list of 14 million of the most common passwords. And we're going to run it with the request file. So if we give the command, this will run the brute force attack. Or at least it should. We'll see if it actually works. Okay, so So it's doing brute forcing right now. Ooh, this is erroring out. That's no good. So FFUF request.txt request proto HTTP. We need to figure out why it's erroring out. Okay, so we've got the post login information, we got the IP address. Let me just double check to see that we've got all the information here. So post host, post login, host, data, cookie. Are we missing a cookie here? I mean, this should be a valid cookie. Let's make one more request. Okay, so here, Molly and test password. Try to log in. No route to host. Did the server go down? No route to host means we can't access the thing. Okay, let's go back to the terminal. And we'll try pinging the machine again. Because we might... The machine might have gone down. That would be weird. So ping IP address. It's not responding anymore. Okay. So we need to restart the machine. I broke it? I guess I did. We'll go back to the room, and then we will... It says that the machine is still up. But we can't ping it. I guess we're going to have to restart the machine. Okay, so here, under lab machine, So let's see, our attack box is this. The target machine, we're going to terminate it, and then we're going to restart it. What do you mean unauthorized? Refresh. Let's reload the page. Oh, did we get logged out? We got logged out. That's weird. That's weird. Okay, we'll go back in. And I've already joined the room. Why is TryHackMe acting so weird? Okay, so we'll terminate this machine, and then we'll restart it. It's the AI's taken over. Maybe. Okay, and then we'll start this lab machine. We're gonna have to wait for about a minute. Okay, we need to wait 48 seconds. Excruciating. So here we're gonna exit the split view in here, and we just need to wait for the machine to come back online. So I think the only thing we need to do is adjust our request.txt file. Although I guess the best thing to do would be to get like a fresh set of information. Okay, I looked it up, by the way. Copy to file is still in burps docs. Yeah, it's just that the context menu was acting kind of weird. Okay, so after we get our IP address, we can try sending it through the Burp Suite browser again. 10 seconds. Okay, so it's 10.144.161.122. Let's go back. So this is 10.144.161.122. Okay, and we'll try logging in again as Molly. And password test. And then click on login. Username or password is incorrect. Okay, great. So this has been recorded. And we'll go back to Burp Suite. And then we'll go over to HTTP history, and then click on the new login request down here. Okay, and then right-click on it. Still no copy to file. Okay, that's fine. So we're just gonna copy everything on our own, and then we'll put this in our request.txt file. Save item. Save item is not it. So delete everything and then paste in the information again. So username Molly, password fuzz. Okay. Save modified buffer, yes. Then we'll rerun the ffuf command. Okay, so this is doing a brute force attack with Molly as the username and using every word in the rocku.txt word list with 14 million of the most common passwords. And if it finds a match, it'll stop and it'll tell us which password it was. Okay, I'm with you. It's been possible in the past. I fed it directly into tools. So it's been a hot minute since I've since I've used Burp Suite to do a lot of like web app security testing stuff, so if you don't use some tools for a good amount of time, you'll forget how to use them. Okay, so this is going, it's already done 48,000 requests. It should return back to us pretty soon. In the meantime, I guess we can take a look at our notes. Okay, so now that we're set up, we can run FFUF and get a sense for what failed responses look like. It looks like failed responses are all size 56, so we can filter out all responses with size 56. So let's go ahead and do that. So we'll run the same command, but we'll filter on size 56, so that we only see responses that are not size 56. So not size 56 is probably a good indication that that it is the correct password. Okay, it's running pretty quick. Okay, the next time we run FFUF, we discover one response that has a different response size, so that's probably the correct password. So I'm not sure if they're going to be using the same password that it was when I recorded this like a couple of years ago, but it could be. The interesting thing is that it's actually giving me all the responses over here, which is not what I want. I only want it to give me the ones that match. So we kind of know what the answer already is. So I'm just gonna create another tab and figure out where that is in the rocku.txt file. So cat user share wordless rocku.txt. It's just showing the progress though. You forget exact options, not how to use them, so we will grep for sunshine, because that's supposed to be the password. And we'll also get the line numbers, I guess. So grep L gives line numbers, right? Nope. Yeah, this is only giving us the progress. Okay, so if we run, we forgot to give an additional argument. So we match the code and then we filter the response size, and then we instantly get the password, which is sunshine. Okay, so we're able to brute force the password using the FFUF program. So we've got one more thing we're supposed to be doing. So the next thing we do is we're just going to go into the website, and then we're going to log in as the Molly user. So the username is Molly, password is sunshine, log in, and then we got a flag. Okay, so the flag is here. I think there might be... Is there any other information on this page? No, there isn't. Okay. So go back to the Try Hack Me page, and then supply the first flag. Okay, and then the next question is, use Hydra to brute force Molly's SSH password. What is the value of flag 2? There is a Hercules. Molly. Is there something related to Molly with Hercules? I'm not sure. But anyways, the second thing we're going to be doing is we're going to be running, we're going to be brute forcing SSH passwords. Another common service for brute force attacks is SSH, especially in easy level CTF challenges. So in more advanced challenges, you're very rarely going to be doing brute force attacks, but in easy challenges, it's fairly common. So there's a number of programs that can brute force SSH, but a popular option is the Hydra program, which is the tool that they're showcasing on this room. So compared to login page brute forcing, SSH brute forcing is much easier. I mean, it's much easier in the command syntax, but there's a lot of obstacles that can get in your way for SSH brute forcing as well. So all you need to provide Hydra is a username or list, a password or list, an IP address, and the protocol name, in which in this case is going to be SSH. Okay, so let's go ahead and get this command syntax. And then we'll go back to the terminal. Where is it? So before I give this, I need to get the IP address, which is in the request file. So the IP address is this one over here. So everybody, this is the syntax of the command we're using. So it's Hydra-L and then the username. So the username is Molly, and then -P, and then the password list. So for this exercise is going to be user share word lists rocku.txt, and then the IP address 10.144.161.122. SSH is the name of the protocol. We run the Hydra command, and then it goes to work trying to brute force the SSH password of the Molly user. So after a little bit of brute force attacking, we see that the login is Molly with the password butterfly. Okay, so we can use these credentials to log into the server. So SSH Molly at 10.144.161.122. It asks us if we want to continue connecting, type in yes, and then type in the password. So butterfly is the password, and now we're logged in, and there's the second flag in here. So THM and then a bunch of hexadecimal stuff. We're going to copy this, and then we're going to go back to the TryAcme room and paste in the flag. So the process of brute forcing isn't super complicated. Well, I'd say that it's not super complicated to compared to other types of network hacking activities. But if you're brute forcing like login pages, there is a number of steps you need to take. For example, recording the login page, the login request, with Burp Suite so that you can feed it to other tools. Although you might be able to get this same information from the network tab. I've never really tried it before though. Usually I record the information inside of Burp Suite. Okay, so we don't have I don't think there's too much more time to work on this. But you can run FFUF to attack login pages. You can also use the Hydra tool itself. And I think we might give that a try. Hold on. Why? Hold on, I don't want to look at this. Okay, Hero Pon. Hello, nice to see you here. Thank you very much for the positive message. I appreciate that a lot. Okay, so using Hydra, they talk about a different like command. So this is the SSH, and do they talk about attacking web forms? Ah, okay, post web forms. You can use Hydra to brute force web forms too. You must know which type of request it is making, so a get or post request. These are methods that are commonly used. And you can use your browser's network tab in developer tools to see the request types and review the source code. So what you would do to get this information, Red Slyfox says, if it was rate limited, would you use the round robin that nullsec was talking about, or another method? So I mean, if we're rate limited, we can slow down the tool. So FFUF and Hydra. So for example, FFUF threads, you can set the speed, the number of requests that you're making per second. What would we call this? So FFUF threads argument. So -T. So the default value for FFUF, for example, is 40 concurrent threads. So this might be too quick for specific types of rate limiting on web applications. You could slow it down to like 10 threads or 5 threads or even 1 thread, depending on what the rate limiting is. So we can, so FFUF enables this kind of behavior. Same thing with Hydra. How much more time do we have on the attack box? So machine expiring soon. So we got 12 minutes to play with this. Okay, so let's use the Firefox browser. So in here, we can go to our network tab. Let's see, more tools, web developer tools, and then we can go over to the network tab here, and then we'll make our request. So it's going to be Molly and the password test. Okay, we'll click on login. And then we see in the network tab here that we made an unsuccessful post request to this domain. So if we click on this, we can see all the information that we sent over to the server. And what we're really interested in is the request part. Wait. Hold on. We're interested in seeing the body. Where's the body? So here's the cookies, here's the headers. Okay, so we're gonna right click on this. We're gonna select right click on the request and then edit and resend. So in the new request portion over here, we can scroll down to the bottom, and then we've got payload. That's weird. This should have our request body data. Let me try that again. Oh, this shut down. Okay. Man. The server shut down. Okay. So I guess we don't get to play around with this web application anymore. Anyways, I guess we're done with Try Hack Me. But if you're interested in playing around more, with this room and doing some brute forcing attacks. So Hydra, this is a pretty good room. There's also a couple of other rooms that talk about brute forcing tools. So if you go over to the search, there's another room called Brute Force Heroes that is also pretty good. Let me see if I can grab that link. Type in brute. So there's Brute It, and then there's Brute Force Heroes. These are both rooms that deal with brute forcing. I'll give you the links. I don't think we've got enough time to cover both of these. Or either of these, rather. Okay, and let's just navigate away from Try Hack Me. So if you do like easy level networking CTF challenges, you're going to come across brute forcing quite a bit. So you're either going to be brute forcing a web login page or an SSH service. It's pretty common. Okay, so let's review the network hacking concepts we learned in this workshop. So brute force attacks. Brute force attacks are attempts to determine legitimate usernames and passwords on online services. Brute forcing is similar to, but not the same as password cracking. We learned how to brute force a web app login page with the FFUF program. And we also learned how to brute force the SSH service using the Hydra program. So what I want to drill into everybody here is that when you're learning how to use these tools, it's very important to take notes. For example, over here, I've recorded the exact types of commands that I used with the tool to conduct the attacks. So sometimes the tools change, so modern versions of the tool might rename like one part of the syntax or another part of the syntax, which is something that definitely happens, especially with really popular tools. But you need to take your notes, and then you can retrieve your notes and do the same thing in the future. Alright, so we've got 3 minutes left. I think I'm going to take a quick break before moving on into the last part of today's stream. So the last part of today's stream, we're going to be taking on the University CTF box from Vulnyx.com. So I'm going to take my break, I will put on the birds, and we'll be back in about 2 or 3 minutes. But in the meantime, watch these birds. We'll be back in just a little bit.
Not every geek with a Commodore 64 can hack into NASA. I mean, these servers have more firewalls than the devil's bedroom. Not every geek with a Commodore 64 can hack into NASA. I mean, these servers have more firewalls than the devil's bedroom.
Okay, everybody, we're back. Alright, so let's go ahead and talk about what we're going to be doing today. So this is the last topic for today. Topic 3 is done, topic 4 is here. And what we're going to be doing is we're going to be doing a CTF box challenge. So what a CTF box challenge is, it's downloading a virtual machine that is vulnerable to some sort of security flaw. We deploy the machine on the same network as our attacker machine. In this case, it's a Linux machine with a bunch of security tools. And what we need to do is we need to scan the machine, identify the security flaw, and then hack into the system until we have super user access. So basically root access, because this is a Linux machine. Alright, so let's go ahead and get started. I will start the machine on my network. I've already downloaded the machine, and I need to start up the virtual machine so they can access it. Should be online in just a bit. I'm just going to close out all of the browser tabs I'm not using because it's kind of annoying to see too many tabs open in the browser. Don't forget my clock. Thank you, thank you. So we're going to put 2 hours on the clock, and we'll see if we can solve the CTF box in 2 hours. If not, we might extend our time a little bit. We'll see. Sacrilege, thousands of tabs. I used to be one of those people. I used to be a person who couldn't close my browser tabs, but these days I can't do that anymore. Anyways, so the first thing we need to do, so the machine is running and it's running on our network. The first thing we need to do is we need to identify where the machine is on our network. So typically we can do a few different ways to identify where this machine is, but the easiest way to do it is to use the ARPScan tool. So ARPScan is going to scan a network range and identify which networking devices are online. Okay, so we identify these IP addresses are online, and it's probably going to be this 42 IP address machine. So from here, so our own address on this interface, which is ETH0, is this one over here. So our machine is also on the network, and it's because the machines are on the same network that we're able to access them. So from here, we're just going to run an nmap scan on this machine and try to identify which services are running. We scan all the ports. We get very verbose output, which means that nmap is going to return back to us before the scan is finished. We're going to run it very fast, but not too fast. Okay, so nmap is able to identify 2 ports that are open, port 22 and port 80. And these are both fairly typical services on remote servers. So port 22 is serving SSH, which is remote login, and this is the version of SSH that is being used. Sometimes very old versions of software can have vulnerabilities associated with them, but in most cases, SSH is not the SSH software is not what you want to be attacking. We also see port 80 open, and port 80 is associated with the Apache HTTP server, and this also gives us information that the OS that is being used to run the machine might be Ubuntu Linux. Okay, so HTTP title, University Shaping the Future. Alright. So we can manually check out this web page if we've got the IP address. So what's the IP address? Here it is. Let me copy it. Okay, and then from here, we're going to open up a new tab and then access the IP address with HTTP. Okay, and it says your journey to global success begins here. Okay, great. And we've got a typical web application. I wonder if we can follow these links. So this is home, programs, about. So this is some sort of single page application, so an SPA. They also have like a web form that we can fill out here. I'm not exactly sure if this is what we need to be attacking right now. The other thing we could do is we could take a look at the web page source and see if there's anything suspicious, especially in the comment section of the web page. Okay, I don't see anything here. So because we've got a web page, we've got a pretty wide surface that we can run all sorts of tools on. So for example, we can run, let's see, let's make a new tab. We'll call this our web app hacking stuff. Yay. So the first thing we'll do is we'll run dirb on the web page to see if it can identify some common endpoints. And it was. Oh, wow. So it's able to identify this particular application. It's called Moodle. I'm not too sure what Moodle is, but I guess we can do some research and figure out what's going on here. So we also see phpinfo.php, which, if it actually runs, it gives us a lot of information about the PHP software that is being used to run the application. We also have an administration endpoint, which could potentially be used to log into the application. So let's go back. So here we can check out phpinfo.php, and this gives us a lot of information about the PHP engine. Learning platform in PHPs possibly? Yeah, I mean, okay, so we've got a so the user that is being, so here's the thing, phpinfo.php, when it's available to you, it can give you a lot of information. But yet you need to know where to look, because the output for phpinformation.php, it's really big. So it's been a while since I've had to deal with this stuff. So we got some PHP variables, the environment. So this lets you know about the file paths that are being used by Apache. It's being run by the www data user, which is pretty typical. zlib, zip. Another thing we could potentially look at is take a look at the installed modules. Sometimes there are some insecure modules that we can take advantage of as well. Yeah, there's just a lot of stuff to look through. Let's go back up to the top. Okay, loaded modules. So these ones over here, typically, I mean, I'm not super familiar with what is secure and not secure for PHP modules. What I would typically do is copy the list of modules and then give this over to the AI. The AI is very good at looking through like big lists of information and identifying like outliers. Are there any insecure PHP modules loaded in this list? Okay. We'll see how it replies. The list includes PHP-related modules, specifically mod PHP. Here's the relevant portion of the modules you provided, mod PHP. If you're looking for other PHP-related modules, the presence of mod PHP indicates the PHP is loaded as an Apache module. Okay, that doesn't answer my questions about whether or not they're insecure. Most modules are pretty secure. It's only a few that are risk factors. I mean, the important thing is that we feed the list, or we look through the list to make sure that there's no really unusual modules that are being loaded. Okay, Apache environment. We got a bunch of file paths. Okay, and we've got the PHP version. Sometimes specific versions of PHP are vulnerable to software exploits. I don't think this one is. So typically what we would do is we'd go over to, let's call this our research tab, and give it a funky color. How about some yellow? And we'd run like a tool like searchsploit with PHP and the version number. So this is gonna look through a list of like known exploits. So in this case, like version 8.3.6. It's not specifically giving us any output here. So we go down to like the base, which is 8.3. Brennan Lovell, hello, nice to see you here. Nullsec says, pick a better AI model. Which AI model would you suggest? Okay, so I don't see PHP 8.3. We see PHP Nuke 8.3. Okay. I don't know, it had a drop down? Yeah, I guess it did. What was it? Model. We can choose any of these. But by default it chooses best. Wait, did it say which model it was using? Up at the top? I don't know. When are you going to end the live? Probably 2 or 3 hours from now. Okay, so the other thing that we enumerated from the derp scan is that there's something called Moodle. Moodle. Can we search for Moodle? Oh, there's a bunch of Moodle exploits. So I guess the first thing we would want to do is we want to identify which version of Moodle is being used. And then we'd look back at the list to see if there's any exploits that match the version of Moodle that's being used. So we can go back and we can go over to... Well, we also saw that administration was a valid endpoint. So this is the one that is being used to log in. They also have like a forgot password function. Sometimes forgot password functions can be abused. Why is PHP so insecure? Why is PHP insecure? I mean, PHP can be made secure. It's just that there's lots of weird little quirks about the PHP programming language that can lead to problems. Moodle, that's the way in. Maybe. So the other thing we could do is we could also check for SQL injection in the login page. Invalid name or password. Invalid username or password, so this is... Well, we don't know. Could it be admin? Or admin password? Typically, we want to try all of these like low-hanging fruit vulnerabilities as well, because you never know what's going to actually get you in. Okay, so there's also like the Moodle endpoint. Oh, okay. So this resolved to a host name. Sorry, a domain name. So university.nix. So this is what we got from the error message. HTTP university.nix. So what we want to do is we want to add this to our list of what are they called? Domains. And we can do that inside of our inside of our etc host file. So sudo nano etc hosts. Okay, so here university.nix is 192.168.212.40, was it 42? 42. Okay, so we'll save this entry out. So whenever we navigate to university.nix, it'll associate that with the specific domain, or sorry, the specific IP address. University.nix. Nope. HTTP university.nix. Hold on. Am I spelling this wrong? Weekly Pickup says, gotta go, I gotta catch up on some of the stream. Have a good night. Good night, Weekly Pickup. Hope to see you next time. Ooh, block. HTTP university.nix. Okay, it's here. Great. Okay, and we wanted to go to the Moodle endpoint. What is this? Welcome to University Moodle. We're excited to have you join our academic community. Great. So we've got... Alright, we've got a bunch of names over here. So, medicine teacher Alan Turing. That's great. I mean, we could record these usernames here. Online course software. Yeah, it looks like it. So we can log in. And so the important thing we want to figure out is which version of Moodle is being used. Because if we can figure that out, then we might be able to identify an exploit that we can use against it. Okay, Moodle is the learning platform for learning management systems, LMS. Oh, okay. So the other thing we could do is we could point another vulnerability scanner at the website. This one's called Nuclei, and we'll give this we'll make this red because it's dangerous. So Nuclei, was it U for URL? Okay, so this will scan the website and give us some vulnerabilities if we can identify them. We'll just leave this running in the background. So Moodle admin, Moodle analytics, Moodle classes, Moodle admin. They've got a bunch of listable directories as well. Huh. Nuclei is new to me. Nikto got old. I mean, Nikto... You can still use Nikto, maybe not on every website, but definitely on like older websites. Because Nikto is really good at identifying like really old vulnerabilities. And we'll just leave this running in the background. So log into university. Some courses may allow guest access. Access as guest. So guest access on any web application is really important to check out. Guests cannot access user profiles. Log in with the full user account to continue. Okay, so let's just go to the regular login page. can we log in as guest here? So the other thing here we might be able to look up is whether or not Moodle has a default admin credentials. So something like Moodle default credentials. Moodle.org. What is the default admin password? There are no default credentials for the core Moodle platform. Well, that's unfortunate. So we also have lost password, search by username, search by email address. I mean, we've got a bunch of usernames. So you're currently using guest access. Okay, so guest access, are we logged in? Did it give us a cookie? Let's take a look at our cookies. So in the event you've got guest access, you might be able to take a look at the cookies for the application, and maybe it's a possibility that the people who run the website might have configured the cookies incorrectly. So what is this? Moodle something? Moodle session. Okay. So this is called Moodle session. Possibly Randolph? Randolph. SQL injection? I'm not sure. Okay, so it says you're currently using guest access. So the other thing we need to do is we need to figure out which version of Moodle is being used. Let's see. You're currently using guest access data retention summary. Retention summary? Okay, we can select the language. We can go to so there's no user like sign up page. Check the metadata in the page. Search for something like version. Nope. Or Moodle. Moodle probably appears a bunch of times. Shows up 229 times. That's a lot. Xmetric, hello, nice to see you here. There's a question mark that's so out of place. So this one over here? Yeah. You're currently using guest access data retention summary powered by Moodle. So Moodle.com. So this is well, this is a legit piece of software. If you wanted to check out Moodle.com, here it is. Got ads. Okay, so while the ads are going on, we'll take a little break. Xmetric, I don't think I've seen you in a while. Welcome back. Okay, let's put on the birds. That's a bunch of birds. We'll be back in about 50 seconds. Okay, so after the big bird leaves, and the other little small bird's gonna come back. And then the big bird comes again. Alright, let's get back to the hacking. So I guess we really want to figure out what version of Moodle is being used. Where can we find the version? Where can we find the Moodle version? Okay, to find your Moodle version, log in as administrator, go to Site Administration Notifications, and the version number will be at the bottom. Alternatively, you can check it without logging in by looking at the Moodle Docs link, usually found at the bottom of the course pages. There's a Moodle Docs link at the bottom of the course pages. Okay, so if we go into university.nix, Moodle. So it says something about course pages. So this is one of the courses. And let's see. Guests cannot access this course. Please log in. So Guests cannot access user profiles. Log in with the full user account to continue. So I guess we need to try to log in from Moodle. So like admin, invalid login, please try again. So I'm thinking to myself whether or not we're supposed to be doing some brute force attacks. Because, I mean, it's possible. It's possible that they want us to brute force this, but I'm not sure. Okay, and we found email extractor, so it was able to get us John at example.com. Alright. Try SQL really quick. That's it. That's it. We're in, of course. Alright, well, try SQL. Sure. Or 1 = 1. This stuff. So we can also try like a double quote to see if anything happens. Sometimes it's single quote, sometimes it's double quote. Is the guest login showing details in the URL? Try a legit user with the guest cookie. Try a legit user with the guest cookie. So, I mean, I wanted to take a closer look at the guest cookie in the first place. Moodle, you're currently using guest access. So we'll take a look at what is this? The cookies. So this is the value. So Moodle session, this thing. So can we copy this? I mean, I'm not... I'm pretty sure the cookie is secure, but I guess we should take a closer look at this thing, right? Thinking of get versus post method. Thinking of get versus post method. So Moodle session. This is the value. I mean, this might be... I mean, it's very unlikely it's base64 encoded. But, I mean, we can check. It said false, secure false, and there are all sorts of insecure settings you can apply to your cookies. Echo out the thing, redirect to base64, decode. Yeah, so it doesn't look like this decodes into ASCII bytes. What were some other endpoints that were identified? Moodle calendar classes. Moodle calendar classes. Well, we can check out this this endpoint as well. Okay. Moodle calendar classes. I wonder if Moodle has like a GitHub repository. You can check it without logging in by looking at the Moodle docs link, usually found at the bottom of the course pages. So the Moodle docs link, scroll down to the bottom of your course page and click Moodle docs for this page. The major version will often appear in the redirected URL. Oh, the redirected URL, so 39 or 44. So what we need to do is we need to identify the proper course page. So it's like courses. Yeah, Moodle/course. Okay, and then take a look at view.php. Guest cannot access this course, please log in. Cannot find a data record in database table course. Okay, so that's not how that should work. Directory listing bad operator. So if we can go ahead and check out the different indexes. So ID equals 3, ID equals 4, ID equals 5, just to see if there are different results. So 10. So 10 doesn't exist. What about 9? Or 8? No. 6. 6, this one exists. 7. 8. Okay, so the courses only go up until ID number 7. So this is also user profiles. Try all the courses. Alexandro, hello, nice to see you here. What is up? Okay, so there's /court/report/ what was the file that we were directed to? Scroll down to the bottom of your course page and click Moodle Docs for this page. Site footers. On many updated Moodle installations, you can simply click the Help button in the lower right corner. What was it? To see the version listed at the bottom. Okay, well, I mean, the Help button doesn't give us this information. Yeah, no, it doesn't. So Moodle course tests. Moodle course tests. I guess we can ask like a specific follow-up question. what specific endpoint on the Moodle app will contain version number information? Kiddo, hello, nice to see you here. Hope you're having a good day. What is up? The Moodle Web Service API exposes site and application version data through a specific central endpoint, handling API function calls. The core endpoint, all web functions for external applications. All web service functions for external applications route through the standard REST server file. To retrieve the exact software version for this endpoint, you must invoke the core website getSiteInfo API function. Okay, I mean... that didn't give me the answer to my question. I was looking for an endpoint. Okay, let's just try a curl command. So if we just do like curl http university.nix/Moodle. Let's see if this gives us, well, this, so Moodle redirects to something else, right? Oh, it doesn't. Okay. We'll pipe this into less. Then we'll take a look at the this is too much information. We just want the headers, actually. So set cookie Moodle session equals this thing. Yeah, there isn't very much info here. We should probably try checking out a few of these other endpoints, because one of these other endpoints should expose like the version of Moodle that's being used. Moodle mod index.html. So this is size 0 though. Mod wiki workshops classes. My classes. My classes. Okay, external privacy, external view page. There's nothing on this page. What was the other link? Privacy, provider. This is also blank. So I'm kind of tempted to go back to phpinfo.php and searching for Moodle. Okay, so we got 99 Moodle.ini. So it talked about like major versions of Moodle being indicated by numbers. Okay, it was white. That doesn't mean it was nothing. It doesn't mean it was nothing. It means that we can't see. We can't see the whatever was loaded up. 99 is not a version. 99 Moodle.ini. The reason why I'm fixating on this so much is that we've got all of these different Moodle exploits here. What is the current version of Moodle that's being used? It's 99 to put it at the end of the load list. Oh, really? Is that like a PHP thing? Or I guess maybe like, you know, common software thing? Linux does it too. There have been SQL injection vulnerabilities on some of these other Moodle versions. There's only one mention of Moodle in here, though. Admin registration. That's kind of a weird looking like endpoint. Admin roles and admin settings, admin registration, admin courses. Access denied. Okay, we don't have a username except maybe the teachers and the admin. Kos, hello, nice to see you here. Why not try with the Medusa login page? That one where the administrators log in. I mean, we could, but we don't have specific usernames, but of course we could try like, you know, administrator or admin. What? Why does the username www.root? There's some really interesting stuff in the source code here. What happens if you click on the teacher hyperlinks? So the teachers, this leads to their user profiles, but we can't access user profiles with guest access. www.root is where the web page gets loaded from. Yeah, the web root. Maybe look for the users in the notes folder. Notes. Grey Wolf Medi, hello, nice to see you here. Notes. You do not have permission to do that. View notes. More information about this error. Taking you to moodle.org? Okay, sure. I guess... Actually, I don't want to go here. So there was like an administration page here. Administration... So admin... This leads us to Moodle login index.php. I mean, we could try doing some brute force attacks here. Let's go ahead and give it a try. Okay, so we need to record this using... We'll record this using Burp Suite, which I have loaded up. So just like the stuff we were talking about earlier, we'll try to log in as admin. Okay, failed login, but this was recorded by the Burp Suite proxy over here. So we will right-click. We will right-click, copy to file. So we'll call this request.txt. Okay, create a list with passwords and teachers and passwords. I mean, we could, but I think I'll do like a brute force attack against admin first, because even though we don't know what the format of the usernames might be, because when we took a look at the names of the teachers, Jane Goodall, right? So Jane Goodall, Frank Wright, Alan Turing. We don't know what format they're using for their usernames. Is it like first name space last name? Is it just first name? Is it first initial last name, so f.write? We're not too sure what the format is. If it was like an email, then email might be a little bit easier to do. But the login form doesn't. It's looking for a username, it doesn't specify email. Let's see. But anyways, over here, we've got our request.txt file. We'll edit this. Okay, username admin and password test. So test is going to be the fuzzing point. And everything else will remain the same. So we'll make a special brute forcing tab just for this. And give it a fancy color. How about some green? So let me see if I can get the ffuf-r request. Let me go ahead and get the syntax for that. I've got it in my notes. For the session I was for the HackerFrog session I was doing just today. Where is brute force attacks? There it is. So the ffuf command is this one right here. I'm just going to copy it. Okay, so it looks like the size that is coming back is going to be this really big size over here. So we're just going to filter on that. So match all, but filter on size. Oh, huh, that's funny. Because they've got other passwords that send back a different one as well. So status 303. Are we locked out? Hold on. Let's go back to the application. This is invalid login. Okay. So now we'll filter on this size, 1524. So the words that come back is, it looks like it's 3184. I guess we need to filter on multiple responses. So there's either status 303 or there's status filter on size 1524 and also on size this one 25091. No. Need to. Okay, so now we've got some stuff. We're filtering on everything we're supposed to, hopefully. Okay, so we'll just leave this running in the background. Cookies notice. What is this cookies notice? 2 cookies are used on the site. The essential one is the session cookie. You must allow this cookie in your browser to provide continuity and remain logged in while browsing this site. When you log out or close the browser, this cookie is destroyed. The other cookie, usually called Moodle ID, it just remembers your username on the browser. Okay. So I guess we can also search by... Oh, we could search by email address. So we found like john@example.com. So if you supplied a correct username or unique email address, then an email should have been sent to you. It contains easy instructions to confirm and complete this password change. If you continue to have difficulty, please contact the site administrator. Okay. So the thing is that this doesn't let us know if the usernames are valid. Error sending password change confirmation email. That's weird. Let's just try like a random username. HackerFrog. Okay, so maybe if you provide a proper username, then it gives you an error message. But if you don't give a proper username, it gives you this message. So let's try admin one more time. Yeah, so it gives you an error message. So admin is probably like a proper username on the system. We still haven't found a proper password. Okay, search by email address. Well, it's been an hour and we haven't made too much progress. So I guess the first way of quote-unquote cheating on one of these Vulnyx boxes is to take a look at the tags that are associated with the... Oh, this is a really big spoiler. So the really big spoiler is this one over here, the specific CVE. You'd basically look up the CVE and then it would tell you what vulnerability it is. I mean, the thing is that we have no way of naturally discovering that, so there's so we probably shouldn't cheat and look that up. We do know that this is a Moodle box. Okay, and anyways, I'm going to take a little water break. Just a second, everybody. Okay, I'm gonna ask my good friend the AI, because maybe the paid AI will give us a better answer. So we are looking for version information on the Moodle web app. What endpoints / web pages would contain this information? We do not have authenticated access. Okay, here are common unauthenticated endpoints where Moodle instances may expose version-related information. So like libupgrade.txt, libupgrade.txt. Okay, we can check it out. So this is probably a version number over here, so 4.4. Actually, wait. So we've got like version changes. So there's 4.3. This probably goes down all the way down to the bottom. And it shows like version 1 point something something. 2.0, 2.3. So the version of Moodle that's being used is probably 4.4, because that's the one that's listed at the top. Okay, so if we take a look at our list of authenticated remote code execution. If we're authenticated, why do we need, well, okay. Authenticated remote code execution. We've got cross-site scripting. So it's, I think we're dealing with version 4. 4.4. So we'll search for Moodle 4.4. There's only one vulnerability here. The other thing we could search for is authenticated remote code execution. I mean, let's take a look at the script. So we would run search exploit and then mirror -m and then the number 52350. Let's take a look at the script. Authenticated remote code execution. So we probably login index.php to extract login token. Pretty long script. Okay, so if you just run the script, it'll probably ask us what parameters it's looking for. So URL, username, password, course ID, CMID, and then command. So we're still trying to brute force the admin user's password over here. Then again, the research tab here, well, the script here says that it's authenticated. So we need to figure out, I guess the first thing we need to do is we need to figure out like which users are legit on the system. I guess we can take a look at the list of teachers. Okay, so Jane Goodall. I guess we'll just copy these names over to a file. Jane Goodall, Frank Wright. Frank Wright, John Keys. Alan Turing, Richard Feynman. And the last one is Marcos Lopez. You know, the funny thing about this is that only one of these teachers has like capitalized first name, last name. The rest of them don't. I wonder if that's like a clue. So the other thing we could do is we could try to confirm these or by using the lost password function. Marcos. So search by username. Search by email address. So I mean, we know that this is university.nix. So this might be like Marcos at university.nix. Oh, I didn't spell that correctly. University. Gotta spell everything correct, everybody. Whoops. The other thing we could do is we could search for Moodle 4.4 exploit. Yeah. So Moodle version 4.4 was affected by several security vulnerabilities. So the most critical include authenticated remote code execution, CVE 2024 something something, authentication / brute force flaws. Okay, so this is probably the CVE that was mentioned in the tags. So over here, so 4.3. Yeah, so this is the exact CVE that is mentioned in the tags over here. So I guess authenticated brute force, authenticated like remote code execution is the way in. The question is, how can we determine what a valid username password is? I guess the other thing we could try to ask ourselves is whether or not we can register a user on the system. So like Moodle user registration endpoint. So to register new accounts programmatically in Moodle, use the core web service function. So there isn't like example curl payload. What? Steps to enable web services. So I thought there would be just like a web page where you could use like a web form to sign up, but I guess not. Web service rest server.php. Let's see if this page exists. This page exists. Okay, because this page exists, maybe we can create a user. You can create such a page. So this API, well, I mean, if this is an API endpoint, so API endpoint details, base URL, function, format JSON, authentication, WS token, but we don't have this WS token. So HTTP method post or get. Post is highly recommended for security. So example curl payload. When making a post request, the URL will contain the function and token. So WS token, we don't know what the token is. Otherwise, we could provide the rest of this. If you haven't configured Moodle for API access yet, you need to set it up in your administration dashboard. I mean, we don't have access to this. Okay, we're not having any success brute forcing the administrator password. The token would show up in burp. Let me check on that. So let's just do the landing page. So we go to the landing page, and then let's see what happens in Burp Suite. Okay, we got our Moodle session, and we see the response. 200 HTTP OK. So we're looking for WS. No. Because we're looking for a WS token. Okay, authentication WS token. But let's suppose that they forgot to include the web service token. So in that case, we're just gonna try sending the curl request, but without the WS token. It might not work, but, well, we gotta give it a try. So this is university.nix/Moodle /web service rest server.php, and we're sending data. WS function core user create users. johndoe@example.com. john.doe@example.com. I mean, let's just try sending this. Okay, this doesn't work because there's a... Where does this go wrong? There's too many... Ah, okay. I think it might be because of, like, square brackets. Secure password is not ended with a quote. Secure password... Oh, that's true. So the post request doesn't get a response. Hold on. Something tells me that the information we're sending here isn't quite correct either. Because when we send the curl request, nothing comes back. This comes back as 403 forbidden. Okay, so we're not allowed to send this information. Brute force attack is still going on. So I guess the other thing we can ask is, like, what is the name of the administrator user? It's probably going to be admin. Okay, the default Moodle admin username is admin. Okay. I mean, there's no default password though. Moodle admin default password. Okay, there isn't one. Moodle doesn't have a hard-coded default admin password. Okay. Well, okay, so if we don't get anything going in about, let's say like 20 minutes, then we'll take a look at a walkthrough to get us going. Because I'd like to make some progress at some point. So we know the version of Moodle that's being used. And we just need to figure out what these username or passwords might be. I guess we could do like a brute force attack with like a username list. Hold on, let's get... So just like what, who was talking about that earlier? Koss was talking about it. Let's go into the teachers. So let's just suppose that they're using just first name. So Jane, Frank, John, Alan, Richard, and Marcos. And we'll go back in, and then we'll save it out as users. So Jane, Frank, John, Alan, Richard, and Marcos. Cypher, hello, nice to see you here. Hope you're having a good day. So we'll save this as users.txt. Okay, is this the last topic? Yeah, this is the last topic for today. It's the long one. Okay, so if we're doing like a login page with brute force with Hydra, like Hydra login brute force. Let me see if I can get my shorthand or my what was it? Like command syntax from my notes. Man, it feels like it's been a really long time since I've done like CTF boxes. It's certainly been a while since I've done like a web-based one. Okay, so actually we can go back to Try Hack Me in fact. So we were looking at that Try Hack Me Hydra room. And they had the command syntax for Hydra. Yeah, post web form. So Hydra username word list, machine IP, HTTP post form, path, login credentials, invalid response. So this is the pattern we're looking for. So I'm pretty sure this is HTTP post form that we're looking at. So we'll just copy this and then we'll go back to our brute force username word list. So we're going to use a capital L for username and capital P for word list. User share word lists rocku.txt. And for username, we'll use users.txt. For the machine IP, this is university.nix. HTTP post form path. So the path to the login page is Moodle, what was it? Moodle login index.php. Login credentials invalid response. Login credentials invalid response. So what was their example for try hack me? Login credentials, the username and password used to log in. For example, username and password. Username and password. Invalid response, part of the response when the login fails. Dash capital V verbose output for every attempt. Okay, so so for the post request, where is it? It's anchor and login token. Anchor and login token and username and password. So we're gonna use everything. All this is gonna be the same for most of it. Okay, username, what was it, user and password pass. So user in here and pass over here. And the invalid response that we get in when it doesn't go through is invalid login, please try again. So we'll copy the invalid response message here. Okay, so there's one special, what is it? One special argument in Hydra which can be used to wrap around usernames, to wrap around username lists, right? So it's hydra-help. So which one was it? Loop around users, not passwords. Effective implied with -x. So we run it with the -u. Okay, and we'll see if this works. I guess a watched clock never, what was it? A watched kettle never boils? So we'll come back to this in just a second. So this was nuclei. I also wonder if there's like a specific tool for hacking Moodle. So Moodle hacking tool. Or Moodle security tool. Not true, it's just boring. Which one is boring? What are we talking about? Moodle security tools. Moodle community-based vulnerability scanner for Moodle that scans for canonical and non-canonical Moodle vulnerabilities. Okay, let's check out the... Watching the kettle is just boring? Okay. So here's like a tool. Unofficial community-based vulnerability scanner for Moodle that scans for... Okay. So the purpose is to help penetration testers, bug hunters, and security researchers. Moodle target URL required a username password or auth username password. So we need simple version check by parsing 404 page. Major minor. Okay, so I mean we could have used this tool to get the version number, but I guess searching specific files is fine too. Okay, so I guess this doesn't give us any output until it finds a valid match. I haven't used Hydra for web page brute forcing in a while. I mean, I guess we could try using this tool. Okay, so what do they want us to do? I guess we can clone the repository. Moodle tool. Git clone this thing. What are the requirements? Requests and BS4. I mean, these are... we don't need to install anything special for this. And how to use the tool? Dive into the badmiddle directory and then install the requirements. Give execution permissions to badmiddle.py. Then run badmiddle.py. If you see the badmiddle logo with help with no errors, you're good to go. Using badmiddle is very simple. Run with the following options. Cyber Sky, hello, nice to see you here. Hope you're having a good day. There's actually a lot of good things in this tool. Python, badmoodle. Okay. You must specify the URL to scan, so badmoodle arguments. So run badmoodle with -u http university.nix/moodle. So this is the base URL. Okay, and what other arguments do we need to give? Username, password, proxy, header, level. Level of test to perform default 1. Simple version check. So -L, so like -L1. Okay, Moodle version. So Moodle version 4.04. 4.04. Nothing specific for 4.04. 4 point something. We have 4.40, authenticated remote code execution. We got cross-site scripting. How are we doing in that brute force? Still going. Okay, so I think what we might want to do is we might want to scrape for usernames or other user information. Level 2, simple and specific version check and confronting pages hash. All the above and plugins, themes, enumeration. Verbosity, random agent, exploit, scrape. Scrape all pages from Moodle and save the result in the JSON file. So I mean, maybe scrape and save it to a file. Results.txt, and we'll run it in level 3, sure. Looking for Moodle plugins and themes, and we're trying to scrape information. Plugin. Update bad Moodle official vulnerability database. Man, it seems so official. Scrape all pages from Moodle and save the results. Okay. In companies, pen testing, is it so hard? Sorry, I'm Lucky. Hello, nice to see you here. Are you talking about legitimate, like, security testing engagements? In most security testing engagements, you're given, like, you're not doing it completely blind. So this is, I mean, what we're doing right now is like a black box. It's like we don't know what the application is. But typically, let's talk about this. So, pen testing engagement, typical scenario. So, I mean, let's talk about like web app pen testing engagement typical scenario. You're given credentials for the app. So usually you're given like credentials for like a low-level user on the app. Sometimes you're given, what is it called? Like source code for the application as well, so you can look through the source code for any potential vulnerabilities. And you're usually given a web app walkthrough. So web app walkthrough usually highlights major areas or major sections of the web app. So typically, when you're doing web app pen testing, you're more set up for success than you are if you're going at it blind. Okay, we're still doing brute forcing over here. Found plugin, insert number of threads, or press enter for default value. Default value, okay. Okay, if we are using an SAST and DAST tools, it would be easy to identify the vuln, right? I mean, scanners, insert JSON file name in which scrape results would be saved. Results.json. Yeah, I mean, typically a lot of web app vulnerabilities are found through scanners. So on a lot of like web app vulnerability pen tests, you're typically using like the paid version of Burp Suite, and Burp Suite scanner is actually able to point. It doesn't necessarily like give the answers to the testers, but it can give the testers a very good indication as to what parts of the website to look at based on the scan results. Okay, so our JSON objects are over here. Man, that's a lot of output. Let's search this for some email addresses. So we'll grep for this pattern. Nope. What about the .nix in general? We're able to find something. Yeah, okay, so university.nix. Is that it? It shows up a few times. Okay, so 20 minutes have gone by and we still haven't really made any progress. So I think we're gonna take a cheeky look at the write-up to help us get unstuck as for the next part of this particular challenge. So let's take a look. Grey Wolf says 3 things stick out to me that are redirects in the lost password link. There's no create user either. So apparently you need to create user. You can't create users with the web form. You have to use it. You have to do it through the API. Well, at least from what I've seen. Okay, so we've got a couple of write-ups. Oh, this came out quite a while ago, huh? This one was done in Notion. Interesting. Alright, let's learn what the heck we're supposed to do on this box. This is not English. I mean, even though this is not English, we could probably get the gist of what's going on. Use AI, have it read the write-up and give hints. Use AI, have it read the write-up and give hints. I mean, I guess we could do that. We could do this. So if we go over here, and then I'm doing a CTF box, but I don't want direct knowledge of what to to do to compromise the Moodle app? Please read this write-up, then provide some hints. Okay, we can give it a shot. I can't access the write-up directly right now. I can give you high-level hints that don't reveal direct step-by-step exploitation details. Okay, this is not what we're dealing with right now. We're still dealing with the Moodle app. That model is awful. Which model should we use? We'll try the Claude one, maybe? Okay, and then we'll Actually, we should be able to ask like ChatGPT, because this is like obviously like a CTF exercise. It still says that they can't read the write-up directly. Anyways, let's just take a look at the write-up then. What language is this? So if I have no idea what language this is. Tablagan Flaglar. Okay, translate at google.com. So we can do detect language. So this is Uzbek. It's Uzbek. Interesting. So I guess we need to translate from Uzbek. Translate page. Oh, there's no... Change source language. Translate from Uzbek? There's no Uzbek available to translate. Alright. So we can just try to get some hints over here. So enumeration, sure. Discover the thing. It's Moodle. Then they run GoBuster. Okay, they add university.nix. And then they go over to recover access. What is this? Forgot password? If the user exists, an email has been sent with the new password. Which endpoint is this? This is university.nix administration. Oh, this is actually not Moodle. Wait. So this isn't the Moodle one. This is just the... Okay. The Americans used some Hawaiian language as their encryption in World War II. That was Navajo. Yeah. Navajo was in a... It was, well, it is. It is an indigenous language. So forgot password here. Recover access. A new password will be sent to the user's registered email. Enter your username. Admin, right? If the user exists, an email has been sent with the new password. But this doesn't... this doesn't give us anything? We need to capture this packet? Okay, let's do this in this browser then. So we're doing forgot password admin. Okay, and then, I mean, I'm pretty sure. So this is forgot password admin. We'll put this in the repeater. We'll send it again. Are you kidding me? Wow, this is so dumb. Generated recovery password. Why would you... Alright, well... This is so dumb. Some devs are extremely dumb. Well... That's why you have to poke everything. That's true. That's true, you do need to poke everything. Okay, so, I mean, is this Moodle? This isn't in the Moodle portion of the website. Okay, welcome admin. News. Default login credentials. Sure. So it's Alan.Turing, John.Keys. Okay, well we got all the... Why would they... This does not look like Moodle. So this is probably the login credentials for Moodle, right? So we would go to university.nix, Moodle, and then try logging in as one of these default credentials, or one of these credentials that are listed here. So it's like Alan.Turing and Turing 2026 AI. Yeah. Invalid login. So this one doesn't work. So we can just go down the list. So John.Keys with this one. Are we logged in? No, we're not logged in. Okay, so we just need to keep on going down. SysOS Master, are you familiar with Moodle? Have you used it before? Because I haven't used it before. Something tells me it's not super rare. Does this one get us in? Okay, this one gets us in. So this one is Richard Feynman. So let's record this. I've set it up before. Okay. More presses will be added progressively. All users are required to change their password immediately after first login. Okay, so now that we've got these credentials, we can use the authenticated remote code execution script. So they're looking for URL, which is http university.nix/Moodle. And then username, and then password. So the username is Richard.Feynman. And the password is this one. Feynman Quantum 26. the following requirements are required. So we need all of these: URL, username, password, course ID, CMID, and CMD. Course ID, CMID, and CMD. So what is... How do we find the course IDs? I guess we can probably look these up. So now that we're logged in, where are we logged in? Over here? No, over here. Okay, and then we can take a look at the courses. So my courses, business, no response. What? So take a look at settings. Okay, course format, appearance, files and uploads, groups, tags. Okay, so what we need to do is we need to look up how to find this information. So the CMD is the command we need to send to the server. You know, typically we would send like a who am I to confirm that we have code execution. The CMID and the course ID, I'm not too sure which values we're looking for. So my courses, business. So it looks like the ID is 3. If we take a look at the link, so ID equals 3. So we'll try plugging in 3. And the CMID, I'm not even sure what CMID stands for in this case. So what is Moodle CMID? Okay, the CMID, Course Module ID, is Moodle's unique identifier for a specific activity or resource. So it dictates user permissions and appears directly in the URL, for example, ID equals something. In the database, this value is stored in the Moodle Course Modules table. Cypher, Happy New Year! Happy New Year to you too. Okay, navigate to any course activity in your browser and look in the address bar for view.php ID equals something something. View.php. So let me see if I can identify this. So my courses. Wait, what? I saw something called RCE. Click on... What do you mean by RCE? What is in this section? RCE add question, grading method highest grade. Is this supposed to be some sort of clue or hint? So view.php ID equals 10. Okay, so the ID, apparently it's 10. Okay, and then we'll give this a go. Okay, so we've got remote code execution on the target. Real civil engineer? Yeah, maybe. That could be it. So we've got code execution. So I guess what we need to do now is we need to set up our reverse shell, our reverse shell handler. So let's see. So this is not SSH access, we'll call this remote access. Okay, and we will run Penelope, and we'll wrap it up with RL wrap on port 443. Okay, so nullsex is probably a hint. Now that you have course info, you should be able to get Moodle's version. I know we already got it. Yeah, okay, so this is our IP address right here. And I think what we need to do is we just need to create like a reverse shell payload that we can send to the target. So maybe something like revshells.com. I guess the first thing we want to do is maybe figure out if we can run BusyBox, because if we can run BusyBox, then we can do like a very nice reverse shell payload. So we'll run the command which BusyBox. Does Metasploit have something? Okay, so we can run BusyBox. So that's that makes it a lot easier on us. So we're looking for the BusyBox netcat reverse shell payload. So we'll just run this command. What is the BusyBox thing? So BusyBox is basically like a utility tool that has a bunch of other Linux tools included in it. So you can use BusyBox to run netcat, or you can use BusyBox to run netstat. So it's basically it's a binary with all the other commands that are bundled into it. Okay, so let's take a look and see if we got our... Yeah, now we're in. Who am I? Don't you need -- always read line and possibly no children? Okay, so we're in. Great. Just lonely. Hello, nice to see you here. And how do I learn to code? I've been learning the basics of how computers work, cloud computing, virtualization, different OSs. Made my own virtual machine with the Linux distro, Ubuntu. Okay. Just lonely. Yeah, I mean, I've got a bunch of good resources for programming. And what I would recommend is that you start learning Python first. It's probably the easiest first programming language for people to learn. Here's a list of different links over here. Take a look at the Python education links. There are a couple of really good courses. So Python Essentials 1 and 2. So put together, this is 70 hours of free course material. It's very good. Okay, let's go ahead and take a little break. We'll put on the birds. Okay, we'll be back in about 30 seconds. I just need to take a little water break. Okay, we'll put the birds away and we'll get back to the
Shall we play a game?
How about global thermonuclear war?
Okay, let's go ahead and we'll call in Mr. Scary Hacker Voice Man. We haven't called him in a while. And he can talk about how we got into this box.
Hey everybody, it's me, Scary Hacker Voice Man. Scary Hacker Voice Man comes in every time we break into a server, and we just broke into this one. Well, Mr. University Administrator, it seems like you enjoy deploying flawed web apps that give people the password when they reset it. That is a big mistake. We managed to break into your web app and then find the credentials for your Moodle app, which we then leveraged into remote code execution through a, what is it called? A known exploit. Maybe you knew about these security flaws in your system, or maybe decided to accept the risk. Well, you accepted the risk, and now we're in.
Okay, so Just Lonely says, I think it was pre-made and no, I was just trying to figure out the stuff. Oh, that's great, that's great. It's still a good start? Yeah, I mean, learning how to create your own virtual machines to work with is a pretty good first step, because when you're learning about Linux, when you're learning about cybersecurity, you might end up screwing up your Linux system, and it's very good to be able to screw up systems that you can easily revert. What I would suggest is figuring out how to create snapshots with your virtual machines, and create a snapshot that you can revert to, just in case your system becomes unstable or like screwed up. Okay, so let's go ahead and get started with our internal. So let's see, what directory are we in? So we're in the edit question. Alright, so we're the www data user. What we would typically try to do is take a look at some low-hanging fruit in this situation. So take a look at sudo permissions. We don't have any sudo permissions. Maybe take a look at what's in the op directory. Okay, so there's a passwords.kdbx file. So this was hinted at in the tags for this particular challenge. So here, where was it? So kdbx crack, git sudo. That's interesting. So kdbx, we can probably move this passwords file over to our own directory. So kdbx is a keep passwords directory. So maybe we can move this over to our own box. So cat passwords.kdbx and then redirect it into base64, and then we can move the file over. So we'll just copy this and then we'll move over here. Nano B64 stuff. Paste this in. And then we will cat out B64 stuff. And then pipe it into base64 decode and redirect into keep pass or passwords .kdbx. Okay. So this is a KeePass password database 2.0. Nullsec says, Tyler just started streaming when he got to raid. Yeah, thank you for letting me know about that, Nullsec, thank you. What did you say KDBX was? So KDBX is a KeePass database file. So if we're able to break into this, then we can get some passwords. for the system. So KeyPass, password, password database. I wonder if there's like a KeyPass John the Ripper tool. Let me search for that. KeyPass John the Ripper tool. Okay, to crack or recover a lost KeyPass master password using John the Ripper, you need to use a companion tool called KeyPass2John. I think I've used this one before. So you run KeyPass2John on passwords.kdbx. Huh. File version 40,000 is currently not supported. So, KeyPass, new database format, XML based. So do we need to update this tool? KeyPass2John. Okay, let's see. Extract the hash with KeyPass2John. Now, how do we update one command only? Which KeyPass2John? So the tool is kept over here. We just want to update this one tool without updating everything else. Probably need the latest version? Yeah, probably. Okay, GitHub, KeyPass2John. Thank you for the link, nullsec. Let's take a look. So if we can just run the thing from the GitHub repository, KeyPass2John converter. Okay. So clone the repository and then run the Python script. Yeah, sure, let's go ahead and do that. So copy the thing, go git clone it. And then run the Python script. Python KeyPass2John on passwords.k something something. Okay, so great. We were able to get the password hash. So we will output it to keep.hash and then move it over to the previous directory. Okay, so keep.hash will and we've got a use for our cracking tab. That's great. So John the Ripper word list on keep.hash. What happened here? Using default input encoding, no password hash is loaded. Oh, John the Ripper, why are you so fickle? John -- word list equals something something format KeyPass. Oh, okay. So we need to specify this. All right. Still, no password hash is loaded. Using default input encoding. Maybe it requires a newer John the Ripper? Maybe. Standard KeePass2 John may experience errors with file versions 4.0 and higher. If this occurs, you may need to use a Python-based extraction tool like brute forcing KeePass database passwords, or updated Python 3 port of KeePass to John to generate the correct hash. Okay, John, format KeePass hash.txt. Okay, we could also use hashcat. Thank you for the command syntax. Nullsec, thank you. Okay, so let's try hashcat. Output.john rocku.txt. I mean, user share wordless rocku.txt. We're running it on keep.hash. Salt value exception. Salt value exception. So is it because this is salted? Okay. Well, I mean, the tags on this machine itself says that there's a tool called KDBX crack. Maybe we should use that one. KDBX crack. Yeah, okay. I mean, it points us towards this this GitHub repository here, KeePass for Brute. I really enjoyed the CTF. It was challenging. Yeah. Hold on. I need to set up a time limit for myself. We'll give ourselves like 45 minutes to try to solve the box. Now that we've actually gotten our initial access. Okay, 45 minutes on the clock. So it's KeePass for brute.sh. So we've got it's a shell script. So we run it directly on the KDBX file without. We run it directly on the KDBX file. Huh. Interesting. All right. Yet another git clone. Sure. Git clone this thing. And we'll just... Is this executable by default? It is executable, okay. So, just in case there's something, you know, malicious in the shell script, I should probably run this through... KD usage, KDBX file word list. Okay, I don't see anything super strange about this, but what command is it running in a loop? Ah, it's using KeePass XC CLI. Do I have this installed? You should probably read it. Yeah, no. I'm taking a look. So it's running KeyPass XC CLI and just, you know, trying a bunch of different passwords. Do I have it installed? Okay, I have it installed. So I can probably just run the script on KeyPass. Now what is the arguments? KeyPass KDBX file word list. KeyPass KDBX file is passwords.kdbx, and the word list is user share word lists rocku.txt. Estimated time remaining 56 weeks. Current estimated time remaining 64 weeks. Estimated time remaining 67 weeks. Well, maybe we can just sit around for 71 weeks. How many? So, okay, there are 52 weeks in a year, so this has taken over a year. Better hope they picked one of the top 100. I hope so. Otherwise, we're kind of out of luck. We'll just leave it in the background. So I'm sure it would have been a lot faster. What? Oh, this is not supported by KeyPass to John yet, so there is no known way to extract the hash and crack it. This tool is a quick and dirty patch for the current situation. It tries to brute force the passphrase testing, provided a word list directly against the DB file. It's almost like KeyPass XE is a good password manager. John the Ripper related code comments and issues. So when was this updated? So this was updated 4 years ago. John the Ripper must have... It must have resolved that issue because, you know, this issue is over 4 years old. Oh, it found the password. Found the password found Ashley. Okay, so I think... Is this a graphic user interface? I can't remember how to use the CLI commands anymore. KeyPass... So how do we run this? KeyPass CLI options command. KeyPass CLI... Show a database information. So DB info. Okay, missing positional argument. KeyPass CLI DB info options database. So options, I mean, we don't know what the options are, but we're looking for passwords.kdbx, password to unlock Ashley. Okay, so what do we have? So name passwords. So how do we dump all the information from the database? Import, open the database. Maybe we need to open the database. Show an entries information. So we'll do open. passwords. So I guess we're running password, we're running like inside the GUI now. Help. Add, analyze, merge, open, quit, show an entries information. How about show? No? Edit an entry, edit a database, create a new database. So we want to, I guess what we want to do is we want to search merge two databases, list database entries. LS, okay, LS. SSH and Moodle. SSH and Moodle. So we probably want to take a look at the SSH entries. So show LS. Show the entry. Arguments, database, name of the database, name of the entry to show. Oh, okay. So there are two databases in here. So show SSH. Username Marcos. Password protected. Password protected. Okay, and we want to retrieve this. Show SSH, and I guess there's going to be an argument. Show the protected attributes in clear text. So -s. Okay, so this gives us the actual password. Alright, so we're going to become the Marcos user. So su Marcos, and the password is this one. Now we're Marcos. Who am I? We're Marcos. So we can just move into his home directory, and we've got user.txt. What else is in here? So there was only one entry. The other thing we can figure out is if this user has user permissions. Ah, this person has git sudo permissions. Git sudo permissions. I mean, I'm pretty sure this is a well-known entry over at gtfobins.org. So we can just look up git, and we've got sudo with git, and we want to get a shell. Okay, this executable can spawn an interactive system shell, so we're running this as sudo. So pager equals bin sh command execute sh something something git p help. Great. Okay, so it looks like we'll just copy the command. We can adjust this a little bit. So the pager, we're gonna bin sh is not, well, sh is best avoided unless absolutely necessary. Usually you can get away with using bash. Hold on. Uh-oh. Where'd my history go? So pager equals this. Git p help. I think we just need to set our pager first. And then we run sudo git p help. Hold on, let me take a look at that thing again. This function can be performed by an unprivileged user. So pager equals bin.sh, command equals exec something something, get p help. So this is, and there are like other variants of this command. So link get exec path. Oh, okay. So we can run this symbolic link into getx. I'm not too sure what getx is in this case. We can give it a shot. So we go here, and then we ln-s bin sh getx. And then we run our sudo command, which is get with the exec path x. Love how the intro to Python says a tool, not a reptile. It's our favorite reptile. Okay, now we're the root user. Yay! Git also uses hooks. Maybe you can make it do anything. You could make it do anything if it has root permissions. Okay, so we're the root user. We just need to wander into the root directory. And then lsla, and we got root.txt. So I'm not super interested in getting flags, but I am interested in like the experience of this. So I don't think I've done like sudo git before. This was interesting. And the other like part of this exercise, the key pass part, that was also pretty fun. The Moodle part was a bit frustrating, but it's okay. I guess I should be more...
What are you?
I'm system root.
Thanks, Nullsec, thank you. I should be more observant when it comes to web apps, because there are 2 web apps on the system, right? So what was it? Over here? So there are 2 web apps. There's the regular web app when you don't go to Moodle, which is over here. And then there's the Moodle web app, and they've got different login. They've got different login pages. So the regular one had an insecure password reset. So this was in the administration endpoint. So you typed in admin. Well, no, you went to forgot password, and then you typed in admin. And then you sent that off. And then in the response, it would give you the password. It would give you the password. Update user admin, generate recovery password, this, whatever password it is. Thank you very much for the follow on Twitch. I'm an NPC, thank you. But yeah, I think this was an interesting thing to take away. BRB ad break. Oh, there's an ad break going on right now. Let's put on the birds. Actually, here's some birds having a bath. Here we go. Okay, we'll be back in about 20 seconds. Okay, let's see if this guy gets back in the bath. Oh yeah, he gets back in the bath. Okay, so I think what we can do is we can do a little write-up on this, because we need to learn We need to learn to be observant. Let's go ahead and try that out. So we'll go over to our good old GitHub, and we've got like 30 minutes to do a write-up. Should be enough time. It's supposed to be a token, and maybe you could redirect that to the email, but instead they just send that there. Yeah, well, I mean, at least it wasn't in plain text. At least it wasn't like sent directly to the web app interface. Okay, so this is Vulnyx. So if you want to do exercises like this yourself, then you want to go over to vulnyx.com, and you can download the virtual machines and put them on your same network. We're doing CTF exercises. Yeah, we just finished a CTF exercise. Now we're gonna do a write-up. Where was I? Let's do it in here. Okay. So, write-ups, are you doing the gardening? Am I doing the gardening? I do some gardening every once in a while. The part I hate. I mean, if you don't do write-ups, you're gonna end up learning the same thing over and over again, which is never any good. So this is a medium difficulty box, and I think this one's called University. But I'm an NPC. Are you a cybersecurity student? Are you working in cybersecurity? Let me know what's up with you. University.md. Okay, so we've got 3 different things we record here. We record actually maybe more than 3, but we record the URL where we can find the challenge. We record the concepts to solve the challenge and the method of solving the challenge. Okay, let's see. Albert Arredios. Hello, nice to see you here. Hacked NASA in 97. Hello. How are you doing? I'm a cybersecurity researcher who works IT help desk for an ISP, and I go to school for cybersecurity. That's awesome. That's awesome. I'm glad to hear it. Always glad to see more cybersecurity people on Twitch. So I guess the VM download link will just provide that. Where are we editing? Here. Okay, and then the concepts we need to understand in this box are password, reset vulnerabilities. We need to understand web app version enumeration. We need to understand KeePass database, hash cracking, and the last one was like sudo git privilege escalation. Okay, I'm an NPC. I honestly just want to get into the fun stuff like assembly and reverse engineering some malware, but I have no time for anything right now. I can't even write my own lately. Cypher says, I hacked vending machines in arcades when I was a kid. What kind of, was it like free games and free stuff from the vending machine, that kind of thing, Cypher? I mean, I've got a lot of links for people who want to learn about reverse engineering and binary exploitation. I keep like a big curated list of resources over here, if you want to take a look. Oh, okay. I guess before you were able to like create fake coins for arcade machines. maybe not now. Okay, so the method to solve, I guess we'll split this off into a few different sections. So starting scans, we've got initial access, and then we've got privilege escalation. Love me some free resources. Yeah, everything that we recommend to people are completely free. So starting scans, there are only 2 ports open on the box. So that's going to be 22 and 80. What else can we include in our starting scans? So the web app, has a vulnerability in the administration web point. At the administration, what is it again? Yeah, so this is just the administration web endpoint in the forgot password function. What Nix distro are you using? Yeah, I'm using Kali Linux. Pretty basic. Where was I? In the administration web endpoint in the forgot password function. And how do you spell that? Forgot. So I guess we can elaborate on that. When we try to reset the password for the admin user, the temporary password. Ooh, that's not how you spell temporary. Is sent back to the user in the response. And this can be observed when we send the request in Burp Suite. Okay, and this gets us access to the base app as the admin user. The admin dashboard also hosts, well, let's see if we can take a look. Is it over here? Unipanel, yeah. So this is dashboard.php, and there's was it faculty? Was it overview or news? This was in the news section. Getting on PC? No worries, I'm an NPC. No worries. So the news section. Also features a list of default passwords for different users. In the news section of the page. These credentials are for a second web app. Was it called Moodle? And you're back. Awesome, awesome. These credentials are for a second web app, Moodle. We try all of the creds and the ones for the... which was it? Richard Feynman, I think? For the Richard Feynman user, are... what is the word? work for us. There you go. Okay, so this is a second web app, Moodle, which is accessible from the /Moodle endpoint. Okay, so from here, we can identify the version of Moodle that's being used, I'm pretty sure. Hold on. How would you easily identify the version of Moodle that's being used? Preferences. Maybe it's in Preferences. Looks like I don't already follow your Twitter. No worries. Okay, user account, change password, calendar preferences, message preferences. Badges. So the thing is that if we want to naturally arrive at looking for an exploit for Moodle, we need to figure out where we would typically find the version information. I suppose we could also just follow what we found over here. What was it? Which file did we use? Ah, okay. I think I asked our good friend the Perplexity AI. Okay, libupgrade.txt on the server root. So let's see if this is true. Yeah, this one. Okay. So Moodle lib upgrade. This is the endpoint where we found the version information. So we found version information for the Moodle app on this endpoint. So Moodle lib upgrade.txt. This lets us know the version being used is 4.4. Okay, we research with searchploit. Moodle 4.4, and we find an authenticated RCE exploit script. Okay, and then we can include a couple of commands we use. So we run search exploit and then we copy the script over. Search exploit, copy the script over, and then run the script with Python. This thing over here. Okay, and I guess this all could have gone into like the initial access portion. So maybe we can cut and paste into initial access over here. So from here, we can run a reverse shell payload with the RCE script to get direct access. Okay, and then privilege escalation. We are running as the www data user. But there is a suspicious file in the op directory. The file is called passwords.kdbx, and it is a KeePass database file. We copy it over to our own box. Then we use a cracking tool to extract the password. Okay, and then I guess we can give the GitHub repository of the tool that we used over here, KeePass for brute. And I guess we can give the command that we used to... We use this command. So what was the command again? KeePass for brute.sh. Yeah, this one. So the reason why we record our commands is so that, you know, in case there's some tricky syntax, we don't need to, you know, look around for it over and over again. Okay, so the tool lets us know the password for the KDBX file. Then we use the what was it? KeePass CLI, KeePass XC CLI tool. To interact with the database. And we might as well give all the commands that we used to get the passwords, because otherwise, I mean, I would probably forget. Yeah, open. KeePass CLI open, passwords.kdbx. And then we issue the following commands. It's like ls, and then show ssh.s. Okay. now we have credentials for the Marcus user. Wait, what was the name of the user again? It's Marcos. Marcos. This user has sudo access with the git command, which has well-known privilege escalation vulnerabilities, which has a well-known privilege escalation path. And we'll just drop the link for the gtfobins.io. Where is it? Darn it, where'd I put that thing? And we'll just, there you go. Okay, so these commands will get us a shell, a root shell. So we can just copy, copy, copy. Where is it? So this link command, and then actually I can just copy both of these. Run this one with sudo, and we're done. Okay, not the most fun part of doing your hacking, but it is a very necessary step nonetheless, because otherwise you're going to have to learn the same lessons over and over again. Okay, so seeing as how we're done, we probably want to... Oh, Nullsec mentioned that that Tyler was on, and as well as Ira Sakai. I don't know who Ira Sakai is. We should probably take a quick look at what their stream looks like. Okay, who is this person? Researching Ormus Academy Alchemy. Ormus Alchemy, listening to Argent Metal, and talking with viewers and friends. A guy who loves InfoSec games, anime, metal, D&B, and talking with friends. Huh. I don't understand what I'm looking at. So they're looking at the Wayback Machine. But the other person that we wanted to take a look at is HackSmarter. Because HackSmarter is someone whose materials we look at quite often. And HackSmarter runs his own company. And he has his own cybersecurity education platform called HackSmarter. So he's doing live hacking actor directory and AMA. He's a very knowledgeable guy. And he's also a very active pen tester who runs his own consultancy agency. So if you ever have any questions to ask about cybersecurity, getting into cyber, and pen testing stuff, he's probably a good resource to ask. So we're going to raid his channel. Raid hack_smarter. And before we go, let's just talk about what we're going to be doing on Friday. So today was the Wednesday stream, and we're doing one last stream this week. On Friday, so that's going to be July 10th, we're going to be doing some puzzle games. We're going to be doing Brute Force Heroes, so more Brute Force stuff. We're going to be doing file upload methods over at HackerFrogs AfterSchool as part of the network hacking course. We need to be able to move our files around from our victim machines over to our attacker machines. and we're going to be talking about how to do that. We're also going to be doing some Pico CTF blockchain challenges. I've never really done very much blockchain hacking before, so it's going to be fun figuring out how that goes. So everybody, thank you very much for coming to today's stream, and we will see you next time. But when you arrive on HackSmarter's channel, if you could give this message right here, OSFrog, hip hop hack, OSFrog, I would really appreciate it, just like this. Alright everybody, HackerFrogs out in 5, 4, 3, 2, 1. See you on Friday, everybody.